Hello, I'm Jason Taylor. Welcome to my comprehensive course on the Git source control system. Since this course is designed to walk you through the basic concepts to mastery of Git, I have several goals for this course. First, I want to make sure you know where to go for help on Git concepts and commands. You should understand the core concepts in Git, including general source control principles. You should have a very good understanding and practice with the main commands, including common options and parameters. You will be able to compare differences with ease. Branching and merging will become second nature as we thoroughly cover both topics. You will become familiar with GitHub, one of the most popular Git repository hosting services available. In doing so, I want you to learn Git well enough that you could teach a friend or a teammate. Finally, I want you to enjoy the bonus material at the end. Bonus content is provided to supplement the course with alternative approaches, tips and tricks, and non-critical skills. In order to accomplish the course goals, the approach I'm going to take will follow this format. First, an introduction to this course, including the main motivation for source control in Git. Then, I will walk through step by step the installation of Git on Windows and the Mac and the initial setup. Once Git is installed, we will dive directly into a hands-on quick win on the command line before going over any heavy theory. I think theory and key concepts will be better understood after some practical experience. After we have a better understanding of how Git works, we'll dive back into the command line by covering the basic commands in more detail. Some of it will be review from the quick start earlier, but I will be adding much more detail and more commands in this section. With lots of changes in our repository, we will cover how to compare the differences within our repository. After all of that, we will cover a major part of Git, branching and merging. Branching and merging are encouraged so much more than in other version control systems that I'm going to cover this in great detail. Along the way, you will be exposed to GitHub, which is the most popular Git hosting provider available. And also, when needed, we will install and configure any tools that are required, including a text editor and a visual compare and merge tool. As promised, I will have tons of bonus content that I will keep adding on a regular basis to keep this course fresh. I believe the core of this course is done, but I'm still working on many additional sections and refinements to this course. So, I have priced this course accordingly. As a student of this course, you'll receive all updates free with your lifetime access. So, you might be curious who I am and why I'm qualified to teach this course. Well, I'm a senior software engineer with over 15 years of experience. I've worked in all sizes of companies, from startups to large enterprises, and I even do freelancing from time to time. In my various roles, I've gravitated towards the unofficial DevOps responsibilities in order to solve problems that commonly vex developers. I have used some type of version control system for most of my career, from CVS to Git, and several in between. In particular, I have trained hundreds of developers in person, as well as thousands online on how to use Git for source control. This course does have a few important assumptions and a target audience. First of all, I assume that you have some basic computer skills. I realize that's a vague requirement, and I suspect if you're able to join this course and start watching it, then you are probably computer literate enough for this course. The next requirement is a bit more tricky. You need to be able to install software on your computer, and that normally requires admin rights. This is generally not an issue unless you are on a work computer. That is, your IT department controls the rights to your system. If you are on a personal computer, then you should have admin rights. If you are unsure, just ask a more computer-savvy friend for help. My next assumption is based on my target audience. I assume you need source control, whether or not you realize that fact. The people that need source control would be anyone that creates original, creative assets like programming source code or web design content, which would include freelancers, software developers, programmers, as well as web and graphic designers. Finally, I assume that you have some interest in learning about Git. This could extend beyond the need for source control directly. For example, you could be an IT manager trying to understand why your technical staff wants to use Git for their next project. To get the most out of this course, I recommend following along as much as possible. Use another monitor or device as a second screen while you follow along with the course instructions. And I may go a bit fast at times, so please pause the video between commands or actions to ensure you follow each step exactly. This course provides lots of supplemental materials, including a listing of every command I typed during this course, diagrams and illustrations for many concepts, and source code examples. This course will evolve over time. I may add additional sections or more bonus content to keep the course fresh and to add more value to my students. So check back often. Finally, connect with me on my website, Twitter, Facebook, or my YouTube channel. The majority of my course will be done with a command line. I certainly understand if you feel a bit intimidated by using the command line, especially if you have never used it before. However, I will walk you through step by step each command along the way. There's nothing wrong with using a graphical client, but I firmly believe starting off with a command line is the best way to learn Git. So, you might wonder why, or perhaps even think the command line is a step backwards. Here are my reasons. First, there is a strong history with the command line in Git. It was originally designed as a command line tool, and graphical clients came later. As a result, new features make it onto the command line well before they are integrated into a graphical client. For me, one of the most compelling reasons is the online help. Nearly all online assistants, websites, blogs, or other tutorials use the command line as the standard way of communicating how Git does something. There are dozens of graphical clients, but everyone has the same commands in Git, with only a few fringe exceptions. Also, the command line has more power. Most graphical clients only implement the core or common commands, but leave off some very powerful options. Only the command line provides all the raw power of Git. Much like my online help argument, going command line allows me one set of commands in Git that will work on Windows, the Mac OS, and even Linux. I will point out any commands, Git or otherwise, that are unique to a platform. Once we have covered the majority of the concepts with the command line, I will introduce you to my favorite graphical clients for Git on Windows and Mac. Additionally, I may create courses in the future that focus on a Git client. If you are already convinced of the virtues of source control, feel free to skip ahead to the next video. However, I know that not everyone is sold on the concept, particularly solo freelancers. I have to admit, I was in this crowd for a while until I accidentally deleted some important source that I had been working on for weeks. Which leads me to my first point. Source control is a type of backup. It's not just a normal backup that's difficult to access or restore. No, instead, it's an ongoing backup of every version of your source that you have made, creating a history or a trail of changes. This allows you to undo changes that you've made or restore from a previous known state. In doing so, you could compare various revisions of your code. For example, what has changed in the last 2 weeks? In the process of moving your exclusive residence of your source from your local system to a shared server, your source can allow collaboration and teamwork on a project. And, while working on a team, sometimes you need to know who to blame for breaking the latest build or other opportunities for learning. Source control supports the concept of branching off to make changes in isolation. This encourages experimentation, but in a safe way, without immediately impacting ongoing new development. Finally, some source control systems provide excellent tools for reviewing code for collaborative learning and improving the quality of the project. As I touched on before, there are several types of people that need version control. Nearly any text-based file can be version controlled, and even the occasional binary should be as well. The first, most obvious group would be software developers, software engineers, and programmers. They typically need version control for programming source files like the ones used for developing Ruby, Java, Objective-C, and any other programming language. However, there are several other types of files that need versioning, like UML diagrams, especially if they're stored as XML documents, or SQL scripts, or text-based configuration files. Freelancers often don't bother with source control. Many feel like it's unnecessary since they don't work on a team or at a company that requires this overhead. I think it's even more critical for freelancers to use some type of version control system, since they are the only ones with a copy of their work, and they often don't have the same support network enjoyed by teams at most companies. I held that same opinion until I made a mistake and lost a lot of hard work. Web designers often use tools that save their mockups as HTML, or in a text-compatible format that is great for source control. Also, any original art for websites should be version controlled. Like web designers, graphic artists should save their original art and assets in version control. In particular, vector graphics like SVG files are XML documents, or other text format files that are ideal for version control. To a certain degree, I even support versioning original Photoshop files. Finally, anyone planning to share their code or contribute to an open source project needs to be familiar with source control, since all major open source projects use it heavily. By this point, I assume you will want to use a source control system of some type. So, what are the options? While there are many types and flavors of version control systems out there, I see two major types: centralized and decentralized, or also known as distributed. Granted, there are several version control systems that have incorporated elements of both in them, but fundamentally, a tool is either one or the other. On the centralized side, we have Subversion and CVS, which are the free and open source options. Commercial offerings include ClearCase, Perforce, and TFS, as well as many others. The main concept with centralized systems is that there is a centralized server that is the ultimate source of truth for a collection of versioned files. This normally means that a network connection is required to the central server for most operations, including just editing a file. On the flip side, the decentralized or distributed approach doesn't mandate a central source of truth and allows for most operations to be local. For example, you could get some meaningful work done while on an airplane crossing the Atlantic Ocean, completely disconnected from your company network and the internet. Source control systems that fit this model include Mercurial and Git. Git is a decentralized and distributed version control system. While Git is decentralized, most people still choose to use it with a central server to serve as the main repository for a project or team. Because of the distributed nature, Git can scale massively. For example, the creator of Git, Linus Torvalds, wanted to create a version control system that could handle the requirements of the Linux kernel project, which he also created. Today, the Linux kernel project contains over 15 million lines of code, with over 1,200 worldwide developers contributing to the project in dozens of active branches. Another key benefit of being distributed is that most operations in Git are local. There are only a few commands that require a network connection. Otherwise, you can work completely disconnected, even performing comparisons and commits completely off-network. Since most operations are local, Git is very fast with the same operations. Also, Git is free and open source, which also contributes to its popularity. Git has a very active community, and there are many resources available online. Also, it is very easy to find developers that already have experience with Git. Because of all these factors, Git has become the most popular version control system. Git's de facto standard status means that Git enjoys wide adoption and integration into other tools used by the development community, including text editors, bug tracking systems, and build servers. Before we dive in, there are just a few concepts you need to know. First, in Git, collections of version-controlled files are kept together in a repository. The repository also contains the history of changes and any special configuration. Generally speaking, a repository would contain all the files related to a specific project or application. Next, you need to know about the 3 local states related to files being managed by Git: the working directory, staging area, and the Git repository, or the commit history. The working directory is the directory or folder on your computer that holds all the project or application files. Files within the working directory may or may not be managed by Git. However, Git is aware of them. Normally, within the working directory is a hidden folder called the .git folder that contains the actual Git repository. The Git repository manages the Git commit history, that is, all the changes that are finalized and permanently part of the Git repository. In between is the Git staging area, often referred to as the Git index. That is a holding area for queuing up changes for the next commit. Since files in the staging area haven't been committed yet, you can move the files in and out of the staging area without impacting the Git repository and its history of changes. The 3 states of Git are specific to the local Git repository, but I like to tack on a 4th state, the remote state. Although the remote repository is just another repository with its own 3 states internally, conceptually, I think of the remote repository as a 4th state, since it is the last step in the basic Git workflow, and since few people use Git without a corresponding remote repository. The last concept is the master branch. Conceptually, branches work like they do in other source control systems. They are timelines that contain your changes. In Git, branches contain commits. When we start off, Git provides us with a default branch named master. Great! That's all I want to cover at this point. I'll cover more concepts later, and while I'm in the demos in the next videos. Before we can get started with Git, we need to install Git on our system. I will show you how to do that on the 2 most popular platforms, Windows and Mac OS X. On Windows, I will walk through the steps to install and verify Git for Windows, which is available from git-sem.com. Now, for my interactions online, I'm going to use Google Chrome as my web browser of choice. Modern versions of Windows come with Internet Explorer, which will work just fine, so this is a personal preference. Installation will be covered in the bonus section later on. There are multiple ways to install Git on the Mac. Starting in Mac OS X Yosemite, which is version 10.10, installing Git has become very simple. Just open up your terminal program and just type git version, and the Mac will prompt you to install either Xcode or the command line developer tools. However, this might not even be needed if you already have installed the latest version of Xcode from the Mac App Store. If you are running an older version of the Mac operating system, or Xcode 5 or below, then you will need to install an extra package called the Xcode Command Line Tools from within Xcode. Or, if you do not already have Xcode and/or don't plan to install Xcode, then use the Git for Mac installer provided by git-sem.com. I will cover these alternative ways to install Git on the Mac, as well as how to install Google Chrome in the bonuses section. As a side note, like in the Windows section, I will use Google Chrome most of the time in order to keep the web experience very similar for Windows users. Safari will work just fine. So using Chrome, especially on the Mac, is very optional and a personal preference. In this video, I'm going to install Git on Windows. So I'm going to open my browser and go to git-sem.com. Now the Git website should detect that I'm on Windows, and I should have this button available for me to download for Windows. So I'm going to click on that, and it should automatically begin downloading. Once Git has been downloaded, run the executable. If Windows prompts you for a security warning, just hit run anyway. And now we're going to step through the wizard. Next. Accept the license, hit next. The default location is fine, so hit next. On this screen, I like to make sure we have at least an icon on the desktop. You can scroll down, see if there's anything else that you want to integrate. Everything else should be fine. Hit next. This is okay as well, so I'm going to hit next. I'm going to select the middle option. In addition to installing Git Bash, it will also allow me to run Git commands from my Windows command prompt. I hit next. For me, I prefer the middle option. These settings can also be changed after the fact using the git config commands. I'm going to hit next. And now Git is going to be installed on my system. I'm going to skip the release notes and hit finish. I'm going to close my browser and fire up Git Bash. So you can see that Git is successfully installed. Welcome. In this video, I'm going to show you how to install Git on the Mac. Now, I'm running a modern Mac operating system. In my case, I'm running Mac OS X Yosemite, which is 10.10. Starting in 10.10, I can install Git directly from the command line. So in my case, I do not have Xcode installed, so if I show you, I don't have Xcode in my applications. Now I'm going to fire up my terminal program. I'm using iTerm2. First of all, let's make sure that Git's not installed. Which Git. So we type Git version, and we see that Git is actually not installed. This is a placeholder to launch the Git installer. So the Git command requires the command line developer tools. So there are two options here. We can either get Xcode from the App Store, or we can click the install button, which will just download and install the command line tools. So unless you need Xcode, I would just install the command line developer tools. So I'm going to click on install, and I need to accept the license agreement. And now the installer is going to download and install Git for me. Once the installer has finished downloading, it will begin the installation phase. Great, it looks like the software has been installed. So I'm going to click on Done. Anytime you install some software, I like to reinitialize my terminal program. So I'm going to close it and then reinvoke my terminal program. So now if I type Git version, Git returns with the version that's currently installed. And in my case, I have in parentheses Apple Git-50, which is the version of Git that Apple provides. All right, so now we're good for now. So let's exit out of the terminal. In order to show the entire Git workflow, including the remote and local sides, I will be starting with GitHub by creating a repository there and then making a copy of that repository on our local system, and finally, synchronizing our changes back up to GitHub. Along the way, I'm going to explain each and every command used and why. I'm going to start off by going to GitHub. While there are several Git hosting services out there, GitHub is by far the most popular. So open your favorite modern browser and then navigate to github.com. Once the page loads, you can sign in or sign up. If you already have an account with GitHub, then click the Sign In button near the top of the page, which loads the sign in page. Use your GitHub username and password to log in to your GitHub account. However, if you are new to GitHub, you will need to sign up for an account. From the GitHub homepage, fill out the sign up form to start the process. You might be prompted for another screen if your initial username is already taken. If so, just fill in that page until you are able to pick a username that isn't already taken. Once you make it to the Welcome to GitHub page, you officially have an account. Currently, GitHub uses the welcome page to encourage you to sign up for a paid level. However, the default is a free account, and that's all we need for this course. At this point, just click on your username near the top of the page. This will load your GitHub profile page. Now, click on the odd-looking icon near the top left-hand side of the page. This is the Octocat logo that GitHub uses. Once you click on that logo, that will bring you to the newsfeed page. It is the page you would normally land on when you just sign in to GitHub, which should have everyone on the same page now. Let's create a new Git repository by clicking on the green New Repository button near the right-hand side of the page. Once the New Repository page loads, you'll notice a form asking for a few pieces of information. For new accounts, there should only be one owner available in the dropdown, and it should be defaulted to your username. Repository name is the name you wish to give your Git repository. I recommend a short but descriptive name in all lowercase, no spaces, and words separated by dashes. I'm going to use GitHub-demo for the repository name. The description is optional, but certainly a good idea. I'm going to type a simple demo repository to show the basic Git workflow. I'm going to leave the repository as public, and then click the Initialize this repository with a README. That will start off our repository with a simple README file. I'm going to leave the other options alone, double-check the form, make any adjustments if necessary, and then click the Create Repository button. Once that is done, the repository will be created and you will land on the main repository page. Now that we've created our first repository on GitHub, we need to prepare our local system before we can proceed. I'm going to be doing most of my work in the command line. On Windows, use Git Bash. On the Mac, use the default terminal application or a third-party terminal program like iTerm2, which is what I'm using. Either way, the Git commands will be the same, so now open your terminal program. By default, your terminal program should put you in your user's home directory, which we can confirm by typing pwd. I like to manage all my projects together in a projects directory within my user's directory. To create that directory, type mkdir space projects, then press enter. Then change into that directory, cd space projects, press enter. Now if we pwd, you can see that we are now within our projects folder underneath the user's home directory. On Windows, if you installed Git for Windows and you are using Git Bash, then you know Git is installed. On the Mac, it is less obvious, so we need to ask Git for the version in order to confirm that Git is available. Git space version. If Git responds with a version number, then Git is installed. Otherwise, you may need to install Git before proceeding. Git requires 2 bits of information before we can do very much. That is the name and email address. If we don't provide that information, Git will attempt to automatically figure it out. However, I have found this process to be rather unreliable. So let's just take care of it right now. Git space config -- global space user.name space, and in double quotes, just put your name. And then next, we'll do a similar command for the email address. Git space config space -- global space user.email space, and in double quotes, put your email address. Press enter. And now let's confirm. Git space config -- global space -- list. Git should list back your name and email address you entered above. Now that our local system is all ready to go, let's return to our browser where we left off, which should be in our new repository's main page. Now, I want to get a copy of this repository onto my local system. The process to do that is called cloning a repository. So, locate the clone options at the bottom of the right-hand side of the page. Make sure HTTPS is selected, and then click the Copy button to copy the HTTPS URL for the repository to your system's clipboard. If, for some reason, that button isn't available or isn't working, just select the HTTPS URL and then copy it into your clipboard manually. Now that's done, return back to the terminal and type git space clone space, and now just paste in your GitHub URL. Double check that line and then press enter. Git will now go out to GitHub and make a full copy of our repository on GitHub to our local system. Doing so, Git will automatically create a directory named after our repository, which we can confirm by typing ls, then press enter, which lists out the contents of our current directory. Now, let's go into our local repositories directory, cd space github-demo. Now if we ls, we can see we have our README file that was created when we initialized our repository on GitHub. Now, if I ask Git about the state of the repository with git space status, git status tells us that I'm on the master branch. The master branch is the default branch by convention for a Git repository. The git status command also tells us master is up to date with origin/master, which refers to the master branch on the GitHub version of the repository. The git clone command automatically set up a relationship back to the repository on GitHub and named that reference origin. Finally, Git tells us the working directory is clean. The working directory is where we do all the work and that Git monitors for changes. We use the git status command to see if there are any changes between the working directory, the staging area, our local repository, and our remote repository. Now that we have our repository on our local system, let's add a new file. For that, I'm going to use the bash commands to create a simple text file. So type echo space and in double quotes the contents of our file, test git quick start demo, and then two greater than signs that pipes the contents of the echo command into a start.txt file. After that, press enter. Now we can see the file in our working directory, ls. Also, we can use the cat command to display the contents of that file, cat space start.txt. Press enter. Now let's see what Git thinks about this file. Git space status. Press enter. Now when we do that, Git says that we have an untracked file. An untracked file is just a file in our working directory that hasn't been added to Git yet. Our change, that is, our new file, is in our working directory. We haven't specifically told Git about it yet. So let's take care of that now with Git's add command. Git space add space and then the name of the file, start.txt. Press enter. Now if we do a git space status, Git tells us there's a new file in the staging area, which Git describes as changes to be committed. So, now that our file is in the staging area awaiting the commit, we haven't committed anything yet. We can still back out the change from the staging area and not impact Git's history in any way. The staging area is designed to allow you to build up several related changes so they can be committed as a single atomic unit. Now, let's move forward by committing the new file into the repository. Git space commit space -m space, and in double quotes, a commit message, adding start text file. Then press enter. Great. Now if I do a git space status, Git tells us that we're back in a clean working directory state, and that our master branch is ahead of origin master by one commit. So, now the new file has been moved from the staging area into the local repository. Since there are no other pending changes, once the commit happens, Git marks the working directory as clean. After the commit, I mentioned the fact that our new file is now on the local repository. The commit is still a local command, which means that our file is not yet on GitHub. So to prove this, let's return to our browser. We should still be on our repository main page, so refresh or reload your browser to refresh the contents of that page. What you should notice is that we still have just the README file on GitHub. So there is one last step we need to do, and that is a push. So return to the terminal and type git space push space origin space master. This version of the git push command specifies the remote name, which is origin, which was set up for us automatically when we cloned the repository from GitHub, and the name of the branch to push, which is master, since it is the only branch we have. Now press enter. Since you are making changes on your repository on GitHub, the git push command will prompt you for your GitHub username and password. Once the push command returns, then we can check the results. If we did everything correctly, our new file should be on the GitHub copy of our repository. Let's verify that by returning to our browser. Now refresh the page again. Now, we should see our start.txt file listed. If I click on the file name, I can see the contents of that file as well. Before moving much further in this course, let's take some time to install a decent text editor for our respective operating systems. While Windows comes with a decent text editor, Notepad, we can do much better by using Notepad++, which is available for free. I will show you how to download and install Notepad++. Then, we will walk through how to make Notepad++ accessible to the command prompt and Git Bash. Finally, we will configure Notepad++ to work seamlessly with Git. On the Mac, I will be using TextMate 2. So in this section, I will show you how to download and install TextMate 2, and then how to configure TextMate 2 to work seamlessly with Git. At the end of this section, I will be providing a listing of commands and the contents to any configuration files that we created. In this video, I'm going to install Notepad++, which is available from notepad-plus-plus.org. I'm going to open Google Chrome and copy this website address and paste it into Google Chrome's address bar. Now I'm going to press enter. Once the Notepad++ website loads, go to the Downloads page. Now I'm going to scroll down just a little bit to find the download button. Make sure you avoid any download buttons that may be from advertisers. Sometimes they are a bit sneaky. But to confirm, we're going to make sure that we got the Notepad++ download. Once you've done that, the installer will begin the download. Once the installer has finished downloading, I'm going to click down on the download. On the security pop-up, I'm going to click yes. This launches the actual installer for Notepad++. I'm going to choose English, but feel free to choose whatever language you speak. I'm going to hit OK. On this screen, I'm going to go Next. I'm going to agree to the license agreement. I encourage you to read through the license agreement, or at least skim through the major parts. Hit I agree. On this screen, we're going to choose our destination folder. I'm going to accept the default location since it's okay. Hit Next. On this screen, feel free to review all these components that are going to be installed. For me, all these are fine, so I'm going to hit Next. And on this screen, you can choose how you want Notepad++ to be configured. The one item here I like to do is click on the Create shortcut on the desktop. That will create a Notepad++ icon on my Windows 7 desktop. Now I'm going to click Install. Once Notepad++ is installed, you'll see that we have the icon over here on the desktop. And I can optionally go ahead and choose to run Notepad++. I'm going to unselect that, hit Finish. So I'm going to go over to my icon that I have on my desktop, double click on it, and Notepad++ loads. Now that we've confirmed that Notepad++ is installed properly and loads once I click on the desktop icon, I'm going to close Notepad++. What I would like to do is make sure that I can invoke Notepad++ from the command line in the future. In order to do that, I need to add Notepad++ to my system's path. So in order to do that, I'm going to open up Windows Explorer, and I'm going to browse to the path where Notepad++ was installed. And if you remember from before, Notepad++ was installed in Program Files x86. Under there, it's under Notepad++. I need to copy the folder path to where the application or executable is located. So this is the file that executes Notepad++. So this is the correct folder I need. So I'm going to go up here to the Windows Explorer address bar, click on it, and it turns into a regular system path. So I'm going to copy the path. And now I'm going to go to my Start menu, click on that, go to Computer, right-click, go to Properties. That will automatically put us somewhere inside the control panel. Once this is loaded, we'll go to Advanced System Settings. Once the System Properties dialog shows up, and it will be on the Advanced tab, we're going to go to Environment Variables, click on that. Now we're going to scroll down under System Variables to find Path. So here we are, we have our path, and you can either double click or click on the Edit button. Once the Edit System Variable dialog shows up for our variable path, I'm going to go to the very end of the path, and I'm going to separate path values with a semicolon. Once I have that semicolon, now I'm going to paste the folder path to where Notepad++ is located. Alright, now I'm going to double check this before I hit OK. Yep, that looks good to me. So now we're going to hit OK. OK again. OK for the third time. And once we return to this system page, we can close out of here. And now we can also close Windows Explorer. And while we're here, I'll go ahead and close Chrome. And now to test what we just did, I'm going to go to the Start menu. And in the search field, I'm going to type CMD in order to find the command line. I'm going to click on it, and you can see that the Windows command prompt shows up. And now I want to type Notepad++ to Notepad, and then instead of plus plus spelled out, it's actually the plus mark twice. So plus, plus, and now I'm going to press enter. If everything was set up properly, Notepad++ should load. So now that we have confirmed this, we can close Notepad++, and we can also close the command prompt. Welcome. In this video, we're going to configure Notepad++ to be our default editor for Git. First thing I want to do is make sure that we can access Notepad++ from Git Bash. So go to the Git Bash icon, double-click to open. Once Git Bash is open, type Notepad and then ++. Press enter, and hopefully Notepad++ will launch. Now that we've confirmed this, let's go ahead and close Notepad++. I like to shorten the command for Notepad++ from the command line to just npp. To do that, I'm going to create a bash alias that will map the Notepad++ executable and a couple parameters to the npp command. So I'm going to use Notepad++ to actually create a .bash rc file to accommodate this. So type Notepad++ space and then .bash rc and then press enter. Now this should be done from your user's home directory. If this is the first time creating this file, then Notepad++ will prompt you if you want to create this. I'm going to say yes. And now I'm going to use the bash alias command to create an alias npp for the Notepad++ command. So the command is as follows: alias space npp, which is our alias name, which is our new command, equals, and then single quotes, the command we want invoked whenever we issue the alias. So that would be notepad++.exe space a single dash multi capital I N S T for multiple instances space single dash no session in all lowercase. Once you've done that, go ahead and save this file, and let's close Notepad++. Now let's go ahead and close the Git Bash terminal. To test out our new bash alias, let's reinvoke Git Bash. Now, when Git Bash loads, it will read the bash rc file and execute any commands we have in it, including our alias command. So now, we should have a new command at our disposal, npp. Let's try it out. npp. And if everything was successful, Notepad++ should launch. Now that we've confirmed that, let's close Notepad++. Alright, let's continue configuring Notepad++ to work with Git. I'm going to go back to Git Bash, and now I'm going to configure Git to use Notepad++ as the default editor. To do that, let's type git config -- global, and then the value core dot editor, then a space, and in double quotes, our command for Notepad++. So that would be notepad++.exe space a single dash multi capital I N S T, then a space, then a single dash, no session. Double check that line, and now press enter. Let's use our new npp alias to check the git config file. So npp space and then .git config. Now this assumes that we're currently in our user's home directory. When that loads, you'll notice that we have a section called core with an entry editor and then our Notepad++ command with our couple of options. Alright, so let's close Notepad++. Welcome. In this video, I'm going to demonstrate how to install TextMate 2 from Macromates. First thing I'm going to do is open my favorite browser and go to macromates.com. Once you're on that homepage, go to the Downloads page. Once you're there, find the TextMate 2. Don't worry about it being in beta status. It's been very stable. In fact, Macromates highly recommends that you install the TextMate 2.0 beta if you are running a modern version of the Mac operating system. So now I'm going to click on the TextMate 2.0 beta download link. This will begin the download process. Once the download has completed, you can either click on the file within your browser or go to the download stack on the Mac OS and then click on the TextMate 2.0 beta tarball. Once the tarball has finished expanding, you should end up with the TextMate application in the download stack, which I can show you is right here. Now we're going to click and hold the TextMate application and drag it into the application stack. Great. Now let's open it up from the application stack. So now I'm going to scroll down and find TextMate. I'm going to click on it. And on modern Mac operating systems, you'll get this warning about opening applications that you've downloaded off the internet. Just hit open, and now you can see that TextMate is open. So while I'm here, I want to go ahead and make sure that TextMate is pinned to my dock. So with TextMate open, I'm going to go down to my dock, and I'm going to Control-click or right-click with my mouse. Then go to Options, Keep in Dock. So now, if I close TextMate by going Command-Q, the TextMate icon should remain in my dock. So if I go down here, so I can see that the TextMate icon is still on my dock. I'm going to select the TextMate icon again, which opens TextMate for me again. I'm going to go ahead and reposition some windows. So I'm going to move this over here. And I'm going to close my download stack. And I'm going to minimize this. So the next thing I want to do is integrate TextMate with the command prompt. So if I go to my terminal program and type mate, currently mate is not available from the command prompt. So I'll go ahead and clear. So if I return to TextMate, so in order to integrate TextMate with the command prompt, I'm going to go to the TextMate menu and then the preferences. Or you could use the shortcut Command, comma. Once the preferences window is open, go to the Terminal tab. The Terminal tab will let us know what instructions we need to do in order to integrate it with the terminal. Most importantly, we need to click on this Install button. I'll be prompted for my password. This requires admin access. Once you've done that, the red dot should turn into a green dot, which means that shell support is installed. So I'm going to move this over here. So now, back on my terminal, I should be able to type mate, and that fires up TextMate. So the next thing I want to do is add this line to my bashrc file. This will make TextMate my default editor with many command prompt programs. So now I'm going to return back to my terminal. I'm going to clear. Now I want to make sure I'm in my user's home directory. So if I do a pwd, you can see that I'm already there, which is my default with my terminal. If I wasn't there already, I could just type cd and press enter. So now I'm actually going to use TextMate to edit my bashrc file. So type mate space dot bash rc. Now press enter. Now your bashrc file may look a little differently, or it may be completely empty if this is a new file for you. So in fact, all this stuff really isn't necessary for what we need right now. So I'm going to just move this off screen. So I'm going to move this over. So the line we need to type is export space and then editor in all caps equals double quotes / USR / local / bin / mate space -W. Great, so now we can save this file and close. So that would be Command S. And we can close this file without exiting TextMate entirely by doing Command W. Great, well let's return back to TextMate. And since we're done adding our shell support, I'm going to go ahead and close the Preferences window and then quit TextMate. And back on the terminal, I'm going to clear. And now one more time, I'm going to invoke TextMate. And you can see that TextMate comes right up. Now I'm going to hit Command Q to close. And I'm going to finish up by clearing again. Alright, now that we've installed TextMate and integrated it with our command prompt, let's return back to the shell. And let's just double check. So if I type mate, it brings up TextMate. So I'm going to quit by going Command Q. So the next step is to integrate TextMate with Git. So to do that, we need to add a Git configuration setting to tell Git to use TextMate as our default editor. So the first thing I'm going to do is list the current configuration settings. So git config -- global, because I want to list the global settings, space -- list. So currently I have a name that I've set up for a fictitious user, Abe Lincoln, and Abe's email address. So the configuration setting we need to set is named core.editor. So let's type git config space -- global, because this setting is going to be a global setting, space core.editor, space, and then double quotes, mate space -W in double quotes. Now press enter. Now let's repeat the command to list our settings. So that's git config -- global -- list. Great. Another way we can confirm these settings is by simply echoing out the contents of the .git config file. So I'm actually just going to use TextMate to do that. So type mate.git config. Now this command should be run from the user's home directory. Press enter. And we can see under the core section an entry called editor, and is equal to our mate command with the -W parameter. Alright, well let's go ahead and close. So I'm going to issue the Command Q to quit. And let's go ahead and clear. I'm Jason Taylor. Welcome to the Git Basics section of this course. We will get to dive into the core Git commands. Yes, some of this section will feel a bit redundant, but I will go into even greater detail and cover even more commands in this section. With a solid foundation in Git theory and some prior exposure to Git, I believe this approach will help reinforce and build upon your comfort with Git. I will show you how to start a project with Git in 3 ways. starting fresh without source code, starting with existing source code on your local system, and joining a project on GitHub by forking and cloning. Once we have a Git repository set up, I will walk through the basic Git workflow from adding and editing files, adding them to Git's staging area, committing to the Git repository, and finally pushing and pulling changes back to GitHub. Then, we will continue working with our repository with some file management related tasks, like renaming, moving, and deleting files. Once we have made several commits within our repository, we will use Git's log command to display the repository history as well as a way to shorten commands with git alias. Finally, I will end this section by showing how to exclude unwanted files from accidentally getting into the Git repository. And along the way, I will share tips and tricks as well as several utility commands. At the end of this section, you will have a very strong foundation in Git. In this video, I'm going to cover how to start a new project without any existing source code. As part of this demo, I'm going to be using some filler text from the Hipster Ipsum website, which is available at hipsum.co. So to start off, I'm going to return to my terminal, and I'm starting off in my user's home directory. pwd shows that I'm in the root folder of my user's home directory. Within there, I have a projects folder, so cd projects. And here, I want to create a fresh new Git repository. To do that, I'm going to use Git's init command. So git space init space and then the name of your project. For this example, I'll call it fresh-project. Now press enter. In doing so, Git created a folder called fresh-project. If I do an ls, you can see that I have a fresh-project folder. Alright, so let's go into it. So cd space fresh-project. Now press enter. I'll go ahead and point out a few important pieces of information here. If I do an ls, you'll see there are no files or folders listed. However, if I do an ls-al, that tells the list command to list all files and folders, including dot files and folders, and -l tells it to list in the listing format. Now you can see that we have a .git folder. That is actually where the Git repository lives. The folder that I'm in now is actually the working folder. So if I go into the .git folder, you can do an ls. You can see all the various folders and files that make up the Git repository internally. So if I go back, now I'm back in the working directory. And I'm going to do one more thing. I'm going to use git status command, which will let me know the status of the Git repository. So type git space status, press enter, and the git status command tells us that we're on the master branch. Now, as described before, the master branch is the default branch that Git gives us in the beginning. We can always create more branches later, but for now, we'll stay on master. Git tells me that I'm on the initial commit, and that I have nothing to commit yet. Now that's because I haven't created any files yet. Well, let's go ahead and do that. So if I head back over to my browser, and you can see that I'm on the Hipster Ipsum website. 4 paragraphs is fine. We're probably just going to use the first one. And it really doesn't matter which option you choose here. We just need filler text. So beer me is the way that we get the text. So I'm going to just take that first paragraph, Control click or right click, and then copy. That puts that text into the clipboard. And now I'm going to return to my command prompt. Now let's create a new file. So mate, space, and then the name of a file. I'm just going to create it hipster.txt. Now press enter. That fires off TextMate. And now we should just be able to press Command V to paste in all that ipsum lorem. Great. Now let's save by doing Command S and close Command W. Now that we've returned back to the command prompt, now if I do a git status, again, Git reminds us that we're on the master branch and that we're building up our initial commit. However, we have some additional information. Git tells me that I have some untracked files, and it sees the hipster.txt file. Well, we're currently in the working directory, so Git is not tracking this yet. To have Git track this file, we simply need to add that file to the Git index or to Git's staging area. To do that, we simply type git space add space and then the file we wish to add. So now I'm going to press enter. Now if we do our git status, Git tells us that we have changes to be committed. That means this new file, hipster.txt, is now in the Git staging area. We have a file that's waiting to be committed, but it's not committed yet. We could back out this file, and it's not going to impact Git's history in any way. However, at this point, I do want to move forward with this file. So now if we type git commit without any extra parameters, Git will invoke our default editor, which currently is TextMate, for our commit message. So now I can type my commit message. So adding new file with hipster ipsum, and on a second line, this was done with TextMate 2. So one advantage of using the text editor for my commit messages is that I have the option of doing multiple line commit messages. Now to use this as my commit message, I will save and then close. Command S, then Command W. So you can see that the commit happened and that it used the commit message that I entered into the text editor. Now, one thing to note is that when the command prompt returns with the commit message, that all the lines are run together. So it's not going to preserve the new line character, but that only happens as part of the git commit command. Those new line characters are being preserved, and I'll show you that later. Additionally, you'll notice that in parenthesis, we have root-commit. That's just letting us know this was the very first commit of this repository. So now, if I do a git status, Git reminds me that I'm on the master branch, and now I have nothing to commit, and that my working directory is clean. So at this point, my new file, hipster.txt, is in the Git repository. So now that change is part of the Git's commit history. Alright, well, we're done for now. So I'm going to back up a level. That brings us back to the projects folder. Do an ls. You can see my fresh project is there. And now if I do a rm-rf, specify the fresh-project, it will delete that folder for me. So no more Git repository. Welcome. In this video, I'm going to demonstrate how to add Git to an existing project. To do so, I'm going to set up a new project using Initializer, which will give me a bunch of source code, and then I'm going to add Git source control to that project. So point your favorite browser to initializer.com. Once that page loads, for this demo, you can pretty much use any configuration. I'm going to use Bootstrap, and then I'm going to leave this as default. Then I'm going to add all these options just to give me some more files. Once I'm done, I'm going to click on Download It. All right, great. Now that it's downloaded, I'm going to make sure it's in my download stack. So go to Download Stack, and there it is, initializer.zip. So now I'm going to return to my terminal, and I'm currently in my user's home directory. So pwd shows that I'm in my root folder in my user's home directory. I'm going to go into my projects folder, and here I'm going to expand that zip file that I just downloaded. So unzip space tilde, which is the way we reference our user's home directory, /downloads / and then the name of the zip file. Once you have that, press enter. So the unzip command should expand everything out. So now if we use the ls command, you should see that we have our initializer folder. So let's rename this folder so it looks more like a real project. So I'm going to use the bash command mv to move the folder, which is another way of renaming, specifying the initializer folder, and giving it a new name, web-project. Now press enter. All right, great. So if I do an ls, you can see that I have a web-project there. If I go into it, cd space web-project, press enter. Now I'm in the web project folder. So if I do a pwd, you can see where I'm at. And if I do an ls, you can see all the files that we got by unzipping that zip file. Great, so I'm going to pretend this is my project, and I need to add git source control to this project. So to do that, I can use git's init command. So if I type git space init and then press enter, Git will initialize a new repository using the current folder as the current working directory. Now if I do an ls space -al, I can see that I have my .git folder, which is where the Git repository actually lives, along with the other files that are part of this project. Now if I do a git status, Git will remind me that I'm on the master branch, which is the default branch that you get when you create a new Git repository. And since we haven't done any commits yet, we are building up to our initial commit. And then Git notices a bunch of files that it's not tracking yet. So in order to add all these files at once to Git's staging area and to the Git index, we're going to type git space add space and then a period. Then we can press enter. Now if we do a git status, Git lists all the files that are part of this project. Now there are a lot more files than we had before. And that's because the period will recursively add all the files that are part of this project. Well, great. Let's continue on by committing. So now type git space commit space, and now I want to provide a commit message inline. So that would be -m space, and then double quotes, put your commit message. I'm using my first commit, comma, inline. Now press enter. So in this case, the commit command used the commit message we provided with the -m option instead of invoking our text editor. I like using this approach if I just have a one-liner that I want to use as my commit message. So let's do our git status. And as expected, after a commit, we have nothing to commit because we are on a clean working directory. So I'm going to show you one last thing. So if I clear, you notice that I have in parenthesis master. And if I do a git status, it says that I'm on the master branch and that I have nothing to commit, and that my working directory is clean. That's because this working directory is part of a Git repository, or being managed by a Git repository, which is being maintained by that .git folder. Again, if I do an ls, with an AL option, you can see that I have that .git folder. If that .git folder was no longer there, this project would no longer be managed by Git. So let's do that. So now if I type rm-rf space and then the folder .git, then press enter. We just deleted the .git folder, and in doing so, we removed all traces of Git managing this project. If I do an ls, you can see that we still have all the files that were part of the original zip file. Well, since I'm done with this example, I'm going to clean up after myself. So I'm going to back up a level. So now you can see where I'm at. I'm just within the projects folder. Do an ls. You can see the web-project directory. So now let's remove it. So type rm space -rf space and then the name of the folder, web-project. So now press enter. And we just removed our project. Do an ls. Nothing's there. Welcome. In this video, I'm going to demonstrate how to join an existing project on GitHub. I have a simple starter website repository on GitHub, and I've established this bit.ly URL to help us get there quickly. So I'm going to select this URL, and now I'm going to go to my favorite browser, and now I'm going to paste that URL into the address bar and press enter. And that should bring up the starter web Git repository on GitHub. This will be under my organization SCM-Ninja. Well, first things first, we need to make sure that we're logged in with a GitHub account. To go over to the options over here and either sign up or sign in. Since I already have an existing account, I'm going to go ahead and sign in. Specify your username and password. Then click on the sign in button. After that, you should land back on the Git repository that we were just on. You can verify that you're logged in by making sure that your username appears in the upper right-hand corner. Once you log into GitHub, GitHub will return you to the repository you started at. You can double check that and make sure that you see the SCM-Ninja organization and then starter web repository. Great, now that we're here as a logged in user, let's go over to the fork button. And now we're going to click the fork button to create a copy of the repository into our personal space. Great, now go ahead and select your user ID. And this is making a copy of that repository into our personal space. Now you should notice that the repository reflects your personal ID and then the repository name. Underneath, you'll see forked from and then the original repository that we came from. Great. Now we have our own personal copy of that repository to work on. Next, we need to clone the repository to our local system. So go down to our cloning options and make sure HTTPS is selected. And if you have this button over here, copy to clipboard, then you can use that. Or you can just copy the URL that's in this text field. I'm going to go ahead and use the copy to clipboard button. And now I'm going to go over to my terminal program. I'm currently in my user's home directory. We can verify that with pwd. Now I've already created a projects folder that I like to put all my Git repositories into. So I'm going to cd projects. This is the location that I will be cloning my Git repository into. To do so, I'm going to use git's clone command. So git space clone space and then paste in the URL that we just copied off the GitHub webpage. Take a moment and verify that you have the right GitHub URL. In particular, you want to make sure that it has your username in the URL. Now press enter. Great, now that the Git repository has been cloned, let's go into the folder that was just created for us. If I do an ls, you can see that Git created a folder named after the repository that we just cloned. This is Git's default behavior with the clone command. So let's go into that folder, cd space starter-web. Once we're in that folder, we can do an ls, and you can see that we have all those files from the Git repository. Also, if I do an ls-al, the A standing for all, and the L for a listing directory, my system will display all files and folders, including dot files and dot folders. At the top, you'll notice a .git folder. That's the actual Git repository. So if I go into it, and then do an ls, you can see the files and folders that make up the Git repository. I'm going to back up. Now I'm back at the working directory for this repository, and I'm going to go ahead and clear. So before I do any work, I'm going to do a git status. This tells us a few things. First, that we're on branch master. Master is the default branch that you get with our Git repository. And since we cloned our Git repository from a remote location, the next line tells us that our branch is up to date with origin master. The name origin is a reference to our GitHub repository. It's our remote reference. And /master is the master branch on that remote repository. Since we just cloned that repository, it makes sense that we're up to date with it. Finally, the last line tells us that there's nothing to commit because we haven't done anything yet, and that our working directory is clean, which, again, makes sense. Welcome. In this video, I'm going to demonstrate how to add new files to a Git repository. First of all, I have a few URLs that I want to bring to your attention. The first one is the bit.ly URL to the Git repository on GitHub that we're using. If you haven't already, go to this URL and fork it into your personal repository. I have a prior video that covers this in detail. The next two URLs will be where I'm getting the filler text for this and other videos for covering the Git basic concepts. Since source files are just text files, then any type of text will do. So starting off, I'm going to be using some ipsum lorem as dummy text in order to cover the basic Git concepts. The first URL is meettheipsums.com, which is a collection of ipsum lorem websites that you can get for filler text. The specific website I'll be using in this demo will be hipsum.co, which is the hipster ipsum website. Now I'm going to go over to my terminal. So back on the terminal, I'm currently in my user's home directory. So if I do a pwd and press enter, you can see that I'm in my user's home directory, which is also notated by the tilde. Within my user's directory, I have a projects folder. So I'm going to cd space projects, and now I'm going to press enter. And if I do an ls, you can see that I have my starter-web repository. So now I'm going to go there, cd space starter-web. Now that I'm there, I'm going to clear. Now I have modified my prompt to always display the current branch in my Git repository. So your screen may look a little different than mine. Please see my bonus content on how to do the same for your environment. So within the Git repository, I'm going to do an ls. So now you can see all the files that are in the working directory. And before I do any work, I'm going to do a git status. So you can see that I'm on the master branch and that it's up to date with origin master, which is the reference back to my GitHub repository. Since we haven't done anything yet, The working directory is clean, which means there's nothing to commit. The git status command moving forward will tell us the difference between the working directory, Git staging area, the actual Git repository that is on the local system, as well as how that compares to the remote repository. So great, now I'm going to clear. And the first thing I want to do is add a new file. And to do so, I'm going to use my text editor, which I've set up in a previous demo, which is TextMate. So I'm going to type mate, and I'm going to call it hipster.txt. Press enter. That's going to invoke TextMate, and it's ready for some text. So I'm going to go over to my web browser, and I already have a tab set up on the Hipster Ipsum website. The defaults are fine, and Beer Me is just the Hipster Ipsum's cute way of saying just give me some text. Great. So now I'm going to just select the first paragraph, copy it, and now I'm just going to go over to TextMate and paste it in. Now it's time to save, which is Command S, and close without quitting, which is Command W. Now I'm going to return to my terminal. So if I do an ls, you can see the hipster.txt is in our folder. So let's see what Git thinks of this file. So if I do a git status, Git tells me that there is one untracked file. It also tells me how to add that file so that Git can track it. So let's do that now. So git, add, and then the name of the file, hipster.txt. Press enter. Now if we git status again, Git tells us something slightly different. It tells us that we have changes to be committed. And then it tells us the new file, hipster.txt. This is Git's way of saying this is in the staging area of Git. That is, this file is not yet committed, but is something that Git is tracking and is awaiting the next commit. So now, in order to proceed forward, we just have to type git commit. Now if I do this without specifying any additional parameters, my default editor will show up for the commit message. Great. Well, let's type a commit message. My first commit. Great. Now let's save and then close. Once we close our editor, Git will use whatever we put into the editor as our commit message. All the hash marks are comments and are not committed. So let's look at our commit. So the git commit command returned master, which is the current branch that it commits on, and then this weird text, BA5, and so on. That's the SHA-1, which is a unique identifier for the commit, followed by the actual commit message, which we entered into our text editor. The next line tells us we had one file changed, which resulted in one insertion. In the last line tells us which file actually was changed. Great, well let's do another git status. Now this time, Git tells us that we're ahead of origin master by one commit. It also tells us that we have nothing to be committed and that our working directory is clean. When you do commit, everything that's in the staging area is committed, which means there's nothing left in the staging area after the commit, and in this case, I didn't have any other pending changes in my working directory. So after the commit, I do have a clean working directory. Also, the git status command keeps track of origin master, which is our reference back to our remote repository on GitHub, and then just lets us know that our repository is just a little different. That's important to know because many of our commands in Git are local. So to illustrate that, let's go back to our remote repository back on GitHub. So this is the Git repository on GitHub that we cloned from, which in itself is actually a fork of the upstream repository. It's on master branch, and so if I do a reload, you'll see the same files that we had from before. There currently is no hipster.txt file here. It just reiterates that the commit command was actually a local operation. It did not impact our remote repository. In order to do that, I'll go back to my terminal here, and the git status command actually tells us what we need to do in order to affect our remote repository. We need to push any changes that we have, actual local commits, up to our remote repository. But before I do that, I'm going to do one other command first. This is the git pull. So if I type git pull origin master, this will update our repository with any changes that may have happened on the remote repository down to our local repository, just to make sure we're up to date before we do any pushes back up to our remote repository. This is a best practice. I recommend always doing a pull before doing a push. So now if I press enter, it tells me that I'm already up to date, which is not surprising since I'm the only one working against that remote repository. However, if you're working on a team and you had multiple developers or contributors putting their code in the same repository, then you might get out of sync, which is why this is the best practice. So now that I'm confident that my repository is up to date with the remote repository, it's safe to push my changes back up to the remote repository. So in a similar command, git push origin master. Now I should kind of explain what origin and master mean here. So the git push command will push any commits from the local repository to the remote repository by reference name, as well as the branch that you want to push. So origin is the name of the remote repository that we cloned from, hence it's named origin. It's just a convention, but I kind of like it. The next parameter is master, which is our master branch. It's the only branch we have right now, but in this command I'm going to specify both the remote reference and the branch name. So now press enter, and you may be prompted for your username and password to get back to GitHub. Since you're making changes to your remote repository, then you need to log in with your credentials. Once you've done that, press enter. And as long as you entered your credentials correctly, Git should push up all your changes that you have on your local system up to the remote repository. So at the bottom, we can see that it confirms that it pushed the changes to my copy of the starter web Git repository on GitHub. It also tells me which commits were involved. So basically it pushed the commit 5C05047 up to BA 5B0F0, which is also master to master. So my local master to my remote master. Well, let's go see if that actually happened. So let's go back to our browser. And now if we hit refresh or reload, we should see a new file. hipster.txt, and even the commit message, my first commit. If we click on the file, you can see the contents of that file. Alright, before I continue, I need to make a quick edit to my git config file. So I'm going to do this directly within TextMate. So I'm going to type mate, and then specify tilde /.gitconfig. For the next few videos, I want to make my changes as myself. So I'm going to change this name to my name, which is Jason Taylor. And I'm going to change my email address, jason@git.training. And that's all I need to do for now. So I'm going to save and then close. In this video, I'm going to continue working with my demo repository. As a reminder, I'm going to be getting some dummy text or ipsum lorem from the Hipster Ipsum website, which is available at hipsum.co. So I'm going to return to my terminal. And as a baseline, I'm currently in my user's home directory. To pwd, you can see where I'm at. And all my projects are under my projects folder. So I'm going to go there now. If I do an ls, you can see that we have the starter web project. So I'm going to go into that. All right, now that we're there, let's do an ls. And let's do a quick git status. Great, so we have a clean working directory, so we can start fresh. And we had started out with a text file, hipster.txt. So I want to continue editing that file. So type mate, and then the file name. All right, let's do another couple lines. Let's go to the browser. And you should be on the hipsum.co website. And let's just generate some more text. Let's copy the second paragraph. Copy. Paste. Let's save. And then close. Now if we do git status, you can see that we have a modified file. For now, let's say that I'm content with these changes and that I want to just directly commit these. So I can actually shortcut the add and commit process into one step. To do that, I'm going to type git commit -a for add to stage, and then m for my commit message. So I'm doing a commit message in line, adding more ipsum text. Now I'm going to press enter. And what just happened is the git commit with the -a parameter will add any changes that are modified into the staging area and then committing directly. This can only be done with files that are being tracked. So the question is, what is a tracked file? A tracked file is any file that Git is aware of and tracking actively. That would be any file that has already been committed into the Git repository, or any file that has been added to the Git index or the Git staging area. So a way to find out if your file is being tracked by Git is use the git ls-files command. So I'm going to type git ls-files. This gives me a list of all the files that Git is tracking in the current repository. For example, I could create another file, mate new file.txt, and I'm just going to add some dummy text, just a test of ls files. I'm going to save and close. Back on the terminal, if I do an ls, you can see that I have my new file.txt, and if I do a git status, Git tells me that I have one untracked file, which is a new txt file. Also, if I do git ls-files, we can look around, and the new file.txt is not listed. However, if I do git add new file, git status, tells me that my changes are to be committed, which we expect. We've added this to the Git index or the Git staging area. If we do the git ls-files again, we now have the new file.txt listed. Alright, so I'm going to continue editing my files in my demo repository. So back at my terminal, I'm going to go back to my project. So I'm currently in my user's home directory. So now I'm going to go directly into my Git repository. Now that I'm here, I'm just going to clear. Let's do an ls. Let's continue working with the hipster.txt file. I'm going to go back to my page that I have with more text. It's going to copy the next paragraph. And I'm just going to add it here to the end. I'm going to save and then close. Do git status. And what's interesting here is the current state of my Git repository. I have a new file, which is new file.txt, which I had from a previous video, and the hipster text, which I just started modifying. Now, I haven't staged any of the files from the modified file, and what Git Status is letting me do is see that I have changes that are both staged and unstaged. So the new file is staged, so it's ready to be committed, and the changes not staged for the commit are not yet ready to be committed. They're just in my working directory. So what I could do is git commit -m, adding new file, and the commit's only going to get the file from the to be committed state, which is the staging area. So now if we do a git status, we still have our modified hipster.txt file, which has not been committed yet. So we have to add that file to the staging area. So I'm going to do that the longer way. Git add hipster.txt. And one of the main points of the staging area is that we build up our changes for the commit. That is, we only want to use the -a parameter in the commit command when we don't want to add any more changes to that commit. We're making a very simple, straightforward edit to an existing file. When we have a change that may span multiple files, then we definitely want to use the staging area. So now if I do git status, our change has been moved into the staging area. And let's modify the file one more time. And go back to my browser. Let's get some more dummy text. And we'll just insert him somewhere in the middle. Save and then close. Back to the terminal. And now if we do git status, so even within the same file, Git can track the difference between changes that are to be committed, that are staged, and changes that have not been staged yet. So now we need to add those modifications. Git add. So you might be wondering why we're using the git add command for an existing file. I like to think of it as I'm actually adding the changes that have occurred back into the git index or back into the staging area. If I do that, git status. So now both of my changes are now in the staging area. So git commit. More ipsum for hipsters. Press enter. Now let's do git status. All right, so we're back to a clean working directory. In this video, I'm going to show you how to recursively add files to your Git repository. As a reminder, I'm using dummy text that I'm acquiring from hipsum.co. So I'm going to go back to my terminal, and I'm currently starting off in my user's home directory. So now I need to go directly to my Git repository. All right, now that I'm in my Git repository, do git status. You can see that I have a clean working directory, which is great. And I want to create a deep nesting folder structure within my Git repository. So now I'm going to use the make dir command with a -p parameter to create this folder structure. If I do an ls, you can see that I have my first level directory, which is level 1. I'm going to go into that. Now that I'm there, if I do a pwd, you can see where I'm at. Let's create a file here. Mate level 1 file.txt. Let's go to hipsum. Just copy some text. Paste. Save and close. If we do an ls, you can see that file here and level 2 directory. So I'm going to go up to the level 2 directory. Now I'm going to create the next level file. Let's just make sure we have new text. Let's change this to 8 paragraphs. And let's add some more filler text. All right, so I'm going to copy some more text. Copy and paste it. save and then close. Back to my command line, do an ls. Have my level 2 file and my level 3 directory. So go up a level. Create another file. Let's just copy some more text. Copy, paste, save and close. Do an ls. I think this is enough, so I'll go ahead and remove this directory. Alright, good enough for now, so it's clear. So let's go back up a few levels. That takes us back to our starter web root of the Git repository. So let's do an ls. So let's do a git status. So the git status command is only going to show you the first level directory. It's not going to show you all the files recursively down. However, I can definitely add all the files recursively by just using an extra parameter in the git add. So let's do that now. Let's type git add space, and if I use a period, it will add all the files recursively from this point forward. Now if I do git status, you can see that level 1 / level 1 - file.txt, level 1 / level 2 / level 2 - file.txt, and so on have been added to the Git index. Now if I want to, I can simply commit those changes. And I'm just going to use my text editor to do the commit message. Adding several files recursively. I'm going to save and close. And the commit command returns, showing that each of those files recursively have been added to the Git repository. Welcome. In this video, I'm going to show you how to back out changes in your Git repository. In my terminal, I'm starting out in my user's home directory. pwd shows you where I'm at. So I'm going to go to my Git repository. If I do an ls, you can see the files that I have currently in my Git repository. If I do git status, I'm currently working with a clean working directory. So let's go up to level 1, so cd level 1, do an ls. You can see I have a level1.txt file. Let's open that up right quick. So you can see that I have these two paragraphs in the current state of the file. Since my working directory is a clean working directory, I know that this version of the file is currently in the Git repository. So this is the committed version of this file. I can come down here. I'm going to add some text. Now let's go back to the Hipster Ipsum website. I'm going to copy and now paste. So now we have 3 paragraphs that are part of this file. If I do a save and then close, now back at my terminal, if I do git status, we have our modified file. So let's go ahead and add this version of the file to the Git staging area. So git add level 1 - file.txt, press enter. So one thing to note is that you can issue most commands in your Git repository from any place within your Git repository. All right, so now if we do git status, we have our modified file. Again, if I open that file up again, this is the version of the file that's in my current working directory that has the 3 paragraphs. So back at the terminal, let's say I decide that I really don't want those changes. So let me clear. Let's do git status one more time. Let's say I'm not happy with those changes. I really don't want them to be staged, or I need to work on something else and this file just isn't ready to be committed yet. So what I can do is follow the instructions that are in the git status command. So what I want to do is I want to back out the changes from the staging area, or unstage. To do that, I'm going to use git's reset command, git reset head, and then the name of the file, level1 - file file.txt. So that command unstaged the file. So if I do a git status, that file has moved back into the changes not to be committed state, which is just the working directory state. If I open up that file, you can see that this file has been unchanged. It's still in my working directory as the 3 paragraphs. So I'm going to quit. Let's say I don't want any of those changes for this file. So I'm going to go ahead and clear. So I don't want any of the changes that I just recently made to that file at all. I just want to get back to the state of that file that I last committed. So if I do a git status, the git status command will actually tell me what I need to do. So I can discard the changes in my current working directory by using the git checkout command. So I'm going to follow the instructions from the git status command. So git checkout, and then 2 dashes, and then the file name. So level1-file.txt. If I do that, and now I do a git status, we're back to a clean working directory. Also, if I open that file up again, you can see that we're back to the state of the file that only has 2 paragraphs. So this is the same state of the file that was last committed. So let's quit. And I'm done for now, so I'm going to clear. Welcome. In this video, I'm going to show you how to move and rename files in Git. So I'm currently starting out in my user's home directory. And now I'm going to go directly into my Git repository. Do an ls. So you can see the files that are associated with my project. Let's do this work a few levels in. So level 1, level 2, level 3. So if I do a pwd, you can see where I'm at. All right, now that we're in this directory, let's do an ls. So you can see we have our level 3-file.txt. If I do a git status, we have a clean working directory. So we haven't made any changes yet. So I could rename this file by either doing it in the operating system using either like File Manager or on Windows Explorer, or through the command prompt, or I could use the git commands to do the rename or the move. To the rename the file, I'm going to use git's mv command. So git mv, the current file name, space, and then the new file name. So in my case, level3-file.txt to just level3.txt. I press enter. Now if I do an ls, Git has already renamed the file at the operating system level. And if I do a git status, Git has staged the fact that the rename has taken place. Now at this point, Git has staged the fact that the rename has taken place, but has not committed this. That means I could back out the rename. But for now, I'm going to move forward with committing it. So git commit -m renaming level 3 file. Press enter, and the git commit command confirms that we renamed our file from level3-file.txt to just level3.txt. And then parentheses, it gives me a confidence level, which is 100%. My recommendation is to always rename your files before you make any changes. This will make it easy for Git to track the fact that the rename has happened. Alright, well let's back up a level. And I'm going to go ahead and clear. Now I'm in my level 2 directory, pwd. So you can see where I'm at. Do an ls. And you can see that I have a level2-file.txt. So now I'm going to rename the file from the operating system level without using Git. So I'm going to do this with bash's mv command. So you notice that I'm not prefacing this with Git. This is actually just a bash command. The file name, and now the new file name. Let's do an ls. You see the file has been renamed. Now if I do a git status, Git sees this as two operations. It sees this as you deleted the old file and added a new file that just happens to have the same contents. So we need to add the fact that we did the rename outside of Git by using the git add command, but with an extra parameter. So git add -a, and the -a will recursively add any changes, but it will also update any files that have been renamed, moved, or deleted. So now if I do a git status, Git now sees that we actually renamed the file. Again, I could proceed forward by committing. Renaming level 2 file. So now I'm going to save and now close. So echoed in the git commit command, Git tells us that we renamed the file from level2-file.txt to just level2.txt. All right, so now I'm going to clear. So my next example is I will rename the file, but then back it out. All right, so now that we're in the level 2 directory, let's do an ls. You can see that we have our level2.txt file. And so for this example, let's rename the file using git to a name that we're going to ultimately back out. So git mv level2.txt to the file named 2.txt. If I do an ls, you can see the file has been renamed at the operating system level. If I do a git status, we can see that Git has staged the rename. And before we commit, let's decide that we really don't want that file named just 2.txt. That maybe we do want that level2.txt, the original file name. So you might be tempted to use the reset command like the git status command tells you to. But there's a simpler way. Just use the git mv command. Git mv, and then the new file name back to the old file name. Press enter. Now if we do an ls, you can see at the operating system level, the rename has happened. That is, we reverted back to the old file name. And now, if we do a git status, we're back to our clean working directory. It's as if we didn't do any changes at all. All right, so now I'm going to clear. And for whatever reason, let's say this next example, we're just going to move the file to another directory. So let's do an ls. You can see we have our level2.txt. Let's move them up to level 3, but we'll keep the same file name. Git mv level 2 up to level 3. Do an ls. You can see the file is no longer in this directory. So we're going to go up a level. Now if we do an ls, you can see the file is here. If we do a git status, Git has staged the fact that we renamed or moved the file from the previous directory to the current directory. Or we can back up a level and do the git status again, and we rename the file or move the file from the current directory to the next level up, which is level 3 directory. So if we commit, so moving file from level 2 to level 3, save and close. We committed the fact we did the rename or the move, and all is well. Do an ls. Again, there are no files in this directory. Just go up to the level 3, do an ls. We have our level2.txt and our level3.txt. And of course, it really doesn't make sense to have a level 2 file in the level 3 directory, so let's move it back. But I'm going to do so without git. So I'm just going to use the bash command, mv, to move the file. So mv, and then the file name, and then the target, which is one level down, which is indicated by the double dots. If I do an ls, you can see that we only have the level3.txt file in the level 3 directory. You can back up a level. Now that we're back in the level 2 directory, do an ls. you can see that we have the level2.txt back in its level2 directory. When we use git status, like before, to git, it looks like we deleted a file and then created a new file. To fix that, we'll use the git add-a. All right, now press enter. Now if we do a git status, Git properly sees that we just moved the file, which is indicated by the file being renamed to a different folder. Let's go ahead and commit, moving level 2 file back to level 2 directory. Save and close. And like before, the git commit command sees that we renamed the file or moved the file back to its original folder. So I'm going to clear and go up a level so we're back to the level 1 directory. It's pwd. So this time I'm going to use my file manager, which on the Mac is Finder, to rename the file. So I can go to Finder. So I'm in my home directory. So I need to go to Projects, Starter Web, Level 1. And now I'm just going to rename the file. So level 1-file.txt, it's just going to be level1.txt. Press enter. Now if I return to the terminal, now that we have renamed the file using Finder, which is outside of Git, you do an ls, you can see that the level1.txt file is there. If we do a git status, like before, Git detects this as two separate operations, a delete and then an add. In this case, I don't want to use the -a parameter in the git add command because the .ds_store file is an operating system level file that I just don't want tracked in my Git repository. So I want to individually add the level1.txt file. Do git add, and then the name of the new file. So this will add the file or the change to the Git index. If necessary, we may need to update the index as well. So git add-u to make sure Git understands that we renamed the file instead of just simply adding a file. So now if we do a git status, Git correctly sees the renaming of the file. So I'm going to finalize this out by committing, renaming level 1 file. Save and close, and we've committed our change. Welcome. In this video, I'm going to demonstrate how to delete files in Git. First of all, I'm in my terminal program, and I'm starting off in my user's home directory. I'm going to go to the Git repository that we've been using. Once in the working directory of the Git repository, I'll show you the files that we have, and if I do a git status, you can see that I have a clean working directory. Alright, so let's get started. I'm going to go ahead and start off by creating a simple file, mate space doomed.txt, and I'm just going to put some filler text in here. This file won't last long. I'm going to save and close. Back on my terminal, let's do an ls, and you can see that we have our doomed.txt. If we do a git status, we can see that we have doomed.txt as an untracked file. So my first deletion example will be to delete a file that is not yet being tracked by Git. If we try to use Git's rm command, git rm, which is the command that we use for removing files, and specify doomed.txt, Git will complain that it can't match the file. That's because Git is not yet tracking this file. So what we need to do is simply use the operating system's facilities for deleting the files directly. In this case, I'm going to use the bash command rm, and then the file name, doomed.txt. Now if we do an ls, the file is gone. If we do a git status, we're back to a clean working directory. And since the file was never tracked to begin with, we didn't have to worry about committing the fact that we made any changes to the working directory. Alright, let's clear. For the next deletion example, I'm going to go ahead and delete a file that is being tracked by Git. So to show you all the files that I have that Git is tracking, I'm going to do the git ls files. And here towards the bottom, we have newfile.txt. We do an ls. You can see that newfile.txt is in our directory. And one way to delete the file that is already being tracked by Git is to use Git's rm command. So git rm, and then the name of the file, newfile.txt. Press enter. Git responds by saying that it issued the rm command. If we do an ls, you can see that the newfile.txt is no longer listed in our directory. And if we do a git status, Git has staged the fact that the deletion is going to take place. Of course, the deletion is not permanent yet. We need to move forward by committing the change that is staged. So let's do that. Git commit -m for the inline message, deleting new file. Now press enter. And now the deletion has been recorded in the Git repository. If we do a git status, we're back to a clean working directory. All right, let's clear. For my next example, I'm going to show you how to back out a staged deletion. So let's do our ls. And hipster.txt is a file that I'd like to get rid of in this repository. If we do a git ls files, we can see about halfway up that we have the hipster.txt listed, which means Git is tracking this file. So let's delete it by using git rm hipster.txt. Git responds saying that hipster.txt has been removed. If we ls, hipster.txt is no longer listed in the directory. And git status shows that the deletion is currently staged. Again, that means the file has not been permanently deleted, at least as far as Git's concerned. However, maybe we're not quite ready to delete this file yet. So let's unstage it. If we do a git reset head and then the name of the file, now be careful because tab completion isn't going to work since that file does not exist in the working directory. So you will have to spell it out exactly. All right, so double check your line and then press enter. So Git now confirms that it unstaged the deletion. However, if we do an ls, the hipster.txt file is still not in our working directory. So if we check again with Git by doing a git status, so here we confirm that Git is detecting that there's a deleted file, that is hipster.txt is currently being tracked, but is missing from the working directory. So the previous command, the reset head, specifying the file, just unstaged the deletion. It did not actually restore the file back to the file system. So effectively, we need to discard whatever temporary changes we've made to the working directory by using the git checkout command, which is also specified in the output of the git status command. So let's do that. So git checkout space -- space, and then the name of the file we deleted, hipster.txt. Now press enter. Let's confirm it, ls. Now we can see that the hipster.txt file is back in our directory. If we do git status, we're also in a clean working directory state. All right, so I'm going to go ahead and clear. All right, so we just covered how to delete a file using Git. What happens if you delete a file that Git is tracking, but you don't use Git to do the deletion? For example, you could delete the file using the command line or using a graphical tool like your file manager. So I'll use the bash command rm to delete the file. So let's do that. If I do an ls, let's go ahead and delete the hipster.txt file. rm.hipster.txt. Notice that we're not specifying Git in the beginning of the command. We're not using Git's rm command. We're using the bash command rm. Now press enter. If we do an ls, The hipster.txt file is no longer listed. However, if we do a git status, Git detects that the tracked file that it had, hipster.txt, is missing from the working directory. And because of that, it's placing that change in the not staged for commit. That is the working directory change. So there's a few ways that we could do to handle this. One way would be to git add -a, which will add and update any changes to the working directory, including renames and deletions. So I'm going to do that. Now if I do a git status, Git now has that deletion staged. So to finalize that, we'll do a git commit. Deleted hipster.txt file. Gonna save and close. So if I do a git status, I'm back to a clean working directory. Now I'm going to go ahead and clear. And let's do one last deletion example. And like before, I'm going to do the deletion outside of Git's initial knowledge. So if I do an ls, we see that we have our level 1 directory. And that level 1 contains files and folders recursively, several levels down. So in this case, I want to remove that entire folder structure. So I'm going to use the bash command rm-rf space and then the name of the folder I wish to delete. The -r will recursively walk the folder structure, while the -f will force the deletion. Be very careful when you're using the rm command with the -rf options, since you could really do some damage. Alright, so now I'm going to press enter. ls confirms that the level 1 folder and all its children are now gone. If I do a git status, Git notes all the files that we have deleted that it has been tracking. So basically all the text files from level 1 down. So to update all those files at once, so in order to stage the deletion of all those files at once, I'm going to issue the git add with the -A option. Now if we do a git status, the deletion of all those files have been staged. Alright, let's move forward. Let's commit this. Git commit -m with the commit message deleting level 1 and all children. Now press enter, and the git commit command confirms that we have deleted all those files as far as Git's concerned. And like before, if we do a git status, we can confirm that we're back to a clean working directory. Welcome. In this video, I'm going to show you how to look at Git's history. So I'm starting off with my command prompt, and I'm currently in my user's home directory. And before we get into our Git repository, let's take a quick look at the help page for the command we'll be using, which is Git's log command. So type git help log. So this will bring up the help for that specific command. So this is how we show the commit history. You can see that it has several options, and I'll show you just a few of them in this example. But since there are so many options available, I figured it was useful to show you how to get to the help page. Press Q to get out of that. If you're on Windows, of course, it'll bring up a web browser for you, so you can close that at this point. And now I'm going to go to the Git repository. So I'm going to cd to that Git repository. If I do git status, I have an untracked file, but that's just an operating system level file, so it's not a big deal. So I can go ahead and clear. So let's just go ahead and see what the default git log command gives us. Git log. So you can see that we have the commit history in reverse chronological order. So the top starts with the last commit. And then we work backwards in time as we go down. So we can go all the way back to the beginning of our history. So the first line is the commit. So the commit and then followed by a long string of characters. That's the SHA-1 identifier. That's how Git identifies each of the commits uniquely, followed by the author's name and email address, the date when the commit happened, and then indented a little bit is the actual commit message. Now, it's not required to see the entire SHA-1 for each of the commits. We can actually see it a little bit shorter. Type Q to quit out of this. I can provide another option. So git log -- abbrev commit. And now in this example, the commit ID has been shortened. Typically, all you need is 6 or 7 characters to uniquely identify a commit in the Git repository. As your Git repository grows in size, the number of characters needed to uniquely identify a commit may expand a bit. So I'm going to quit out. So now I'm going to add a few more options and change the view even more. So I'm going to use git log -- one line -- graph -- decorate. So what this will do is display the log command, but this time the -- one line will compress our entries into one line. -- graph will provide an ASCII graph depicting the branching graph. -- decorate will add any labels or tags or anything that sort of annotates our commits. Now if I press enter, I have a very different view of my commit history. So at the very top, we have the master branch currently pointing to the latest commit. And several commits further down, you can see that origin master is pointing to an earlier commit. Now I'm going to press Q to get out. So if I want to, I could specify a range. So in this case, I'm specifying the first commit down to a few commits later, which is the 761B911. Press enter. And the git log command will only show me those commits that I'm interested in. Another option that you could use with the git log command is date-based searching. So now let's type git log -- since equals, and then double quotes, 3 days ago. This will just bring up the commits that have happened in the last 3 days. And you clear. So now let's look at the specific history of an individual file. Let's do an ls to see the files that we have. And let's just look at hipster.txt. So git log. And to specify a file, you need to use -- space and then the file name. Great. So in this case, the git log command returns with the commits that involve that specific file. It's clear. Let's look at a file that we've renamed. All right. So if we use the command git log -- follow, that will follow the renames, -- space, and then the path to the file. We can see the commit history for that specific file going through the renames. Let's go ahead and clear. Now I'm going to use git show command to show information about a specific commit. So git show, and then I pasted in that commit ID from the prior example. So you can see that it shows the commit ID, the author, the date, and then the commit message, as well as the diff information, basically what changed. Welcome. In this video, I'm going to demonstrate how to set up aliases within Git. So I'm in my terminal program, and I'm starting out in my user's home directory. Now I'm going to change directory into my Git repository that I've been working with. So cd projects starter-web. Do an ls, you can see the files that are part of this project. And Git status shows that we have a clean working directory. Go ahead and clear. So Git has the ability to basically create extra commands that work alongside with Git. And these commands can be an alias for another command, including passing parameters around. So for example, in one of the previous videos, I covered how to look at Git's history. So if I do a git space log space -- all -- graph -- decorate -- one line, I get a really neat looking history of all my commits in my Git repository. But that's a lot of typing to do for each time I want this particular output. So what I can do instead is create my own command, that is a git alias, that will give me the exact same output, but with a much shorter command. So let me first show you the command doesn't exist yet. Git hist. So Git replies back that it's not a command yet, and tries to give me some useful help as to what I might mean. So now I'm going to create my own hist command. So to do so, I'm going to piggyback off of Git's config command. So if I type git space config space -- global, because we want this alias to be available regardless of my repository, so that will be saved at the user level, space, and then alias dot, and then name of the command. So basically any configuration setting that starts with alias dot will allow us to create an alias named after the command. Space, so in double quotes, I'll put the full command that I want issued, leaving out the git part of the command. So in this case, we just start with log space -- all space -- graph space -- decorate space -- one line. Now, double check that line and then press enter. Now, let's try it out. Git space and then the name of your alias. In my case, hist. If you're successful, then you should have the exact same output as above. So now I'm going to clear. And let me just show you where the aliases are stored so that you can modify them if you need to. And since we're using Git's config command to actually store the aliases, we need to open the .git config file in your user's home directory. So mate -- .git config. Press enter. And that opens up our .git config file. And all aliases will be under the alias section of your Git config. You can see the name of my hist alias and then the full command. So I could modify this if I wanted to. For example, if I wanted to, I could take the graph out, save and then close. So now if I do a git hist, so now I don't have the asterisks that represent the graph line. Now I'm going to quit. Let me go ahead and edit that file again because I actually do like the graph. So I'm going to go ahead and put that back. Save and then close. Git hist. Yep, I'm back. Welcome. In this video, I'm going to demonstrate how to exclude unwanted files from our Git repository. I'm in my terminal program, and I'm currently located in my user's home directory. So now I'm going to change directory into the Git repository that I've been working with. So cd projects / starter-web. Okay, now that we're in my Git repository, if we do an ls, we can see all the files that are part of this project. And now if we do a git status, you can see that we do not have a clean working directory. However, the file that is here, that is untracked, is a file we don't want tracked. The .ds_store file is a Mac operating system level file that we definitely don't want tracked in my Git repository. Now, I could leave it here and just work around it and being careful not to add that file accidentally. But I know that eventually I'll end up adding that file accidentally, and Git does provide us an ability to exclude that file. So let's go ahead and do that. The facility that Git uses is a text file called .gitignore, which Git uses to track all the files and folders that Git should ignore. So let's look and see if we have a .gitignore file in our repository yet. So if I do an ls space -al, that will list all files, including the dot files and folders. So in this case, we don't have a .gitignore file yet. So let's create it. So type mate space .gitignore, then press enter. And the format for this file is one expression per line. The expression could be the name of a specific file, the name of a folder, or a pattern like *.txt. Well, I'm just going to exclude the specific file for now. $DS _ S, and then store. All right, now it's save, and then close this file. Now if we do an ls -al, you can see that we have our .gitignore file in our working directory now. Let's check out our git status. And now you can see that our .gitignore file is already working. So instead of the .ds _ store file, we have the .gitignore file. The .gitignore file is a text file like any other file, and it needs to be added to Git for version control. So let's do that now. Git add .gitignore. Let's do a git status. Git sees our .gitignore file as a new file. And let's go ahead and commit. Git commit. And now when your text editor shows up, adding git ignore file to exclude unwanted files. All right, now it's save and close. Doing so actually commits the file. If we do git status, we're back to a clean working directory state. Now let's do one more example with the gitignore. Let's say that we have our web project. If you do an ls, you can see that we have HTML files here. And we deploy this and test this out with Apache. But for some reason, we have Apache to log in the same directory as the rest of our files. So that might result in an access log file. So I'm just going to create a quick log file that would replicate what Apache might be doing. So mate, and then access.log. All right, so just making up a few lines, nothing special, just to replicate a super simple log file that a web server might be logging. So I'm going to save and close it. And if I do an ls, we can see that we have our access log. If we do a git status, Git sees our untracked file. Let's go ahead and exclude that log file. So mate.gitignore, open that up. And this time, I know we may have some other log files, so let's do a pattern this time. So we're going to do an *.log. So any file that ends with a .log extension will be captured by this exclusion. So I'm going to save and close. Let's go ahead and clear. So now if I do a git status, you can see the log file has been excluded. So another scenario with Apache might be that it's logging into a log directory, and there might be some rotation going on, so we can't always rely on a file ending in .log. So let me replicate that right quick. So I'm going to make a log directory, and I'm going to move our access log over there. If I do an ls, we have moved our access log. So now I'm going to go into the log directory. And I'm just going to make a copy of this right quick and name it after some date pattern. So now I have two files. So let me go back one. And now let's do a git status. So it sees our modify.gitignore file, but it also sees an untracked log directory. And that's because there are files in there that would qualify to be added that aren't being excluded yet. So let's modify our .gitignore file again. So since *.log isn't going to be generous enough to exclude everything we need, but we do know that all the log files will be going into the log directory, we can specify just the log directory. Now if we save and close, back at the terminal, let's go ahead and do git status. We're back to just the modify gitignore file. So Git is now ignoring the entire log directory and any of its contents. So I'm going to go ahead and commit our .gitignore file using the shortcut git commit -am. That will add any modified files to the index first and then commit it. And then the M will allow us to specify our commit message inline, which is excluding log file directory. Press enter, actually does the commit. So if we do a git status, we're back to a clean working directory. Welcome. In this video, I'm going to finish off this section on basic Git commands by synchronizing our changes back up to GitHub. I'm going to return to my browser and to my starter-web repository back on GitHub. This is the personal copy of the Git repository we originally forked off of the SEM Ninja version of this repository. As you can see, this repository is in the state that we last left it. If I go over to commits, you can see we only have 2 commits. So now I'm back on the main page of my GitHub repository. Well, I'm going to go back over to my terminal, and in my terminal, I'm starting off in my home directory. Now I'm going to go into my local version of the Git repository. Great, now that I'm here, I'm going to do an ls. You can see the files that we have that are part of this repository. And a git status shows that we are in a clean working directory. However, I'd like to point out that git status is telling us that our master branch is ahead of origin master by 14 commits. That's all the local work that we have recently been doing as part of this section. So before continuing on in this course, I'd like to go ahead and synchronize all these changes back up to GitHub. Alright, so I'm going to clear. And like I've said before, it's a best practice to pull changes down before making any pushes. So git pull origin master. And as expected, we are already up to date since we haven't made any changes from any other location back to our GitHub repository. So now let's push our changes back up. Git push origin master. So as I said before, origin refers to the name of the remote repository that we've given in this repository. It refers back to the GitHub repository. And master is the default branch that we have in our Git repository. So now I'm going to go ahead and press enter. And it looks like we have successfully pushed up all our changes back to GitHub. So let's go to the browser and verify that. So back on GitHub, let's go ahead and reload this page. So now we have 16 commits that are part of the GitHub repository. So I click on that, you can see the entire history. The next few sections will focus on comparing, branching, and merging. So now is a good time to install a visual compare and merge tool. While there are several choices available, P4Merge from Perforce is an exceptional tool that is freely available on the Mac and Windows. On Windows, we will download, install, and configure P4Merge to work with Git as both the visual compare and visual merge tool. Like Windows, we will download and install P4Merge on the Mac and then configure it to work with Git for comparing and merge conflict resolution. At the end of this section, I will provide a listing of commands and the contents to any configuration files created. Welcome. In this video, I'm going to show you how to install P4Merge, which is a free tool that's available from Perforce. I'm going to go to Google Chrome, start it up, and now I'm going to copy this web address and paste it into the address bar and press enter. Once the Perforce website loads, I'm going to go to Products, and I'm going to look for Perforce Clients and Tools. Now this might change from time to time as the Perforce company updates their website. I'm going to click on that to load this page, the Perforce Clients and Tools page. And once this page loads, I'm going to scroll down to find the visual tools and find the product named Visual Merge and Diff Tool. I'm going to click on the download icon, which is going to bring me down to an area called Perforce Clients. I want to scroll down and make sure I find the P4Merge Visual Merge Tool. I want to confirm that I have Windows and that it's 64-bit. Feel free to select the correct edition for your version of Windows, and just make sure you have the latest version selected, and now hit Accept and Continue. On this page, I'm going to simply skip registration. The registration page is optional, so if you wish to register, feel free. However, I'm just going to skip. And the P4Merge Visual Diff Tool is going to begin the download. Once the installer has finished downloading, I'm going to click on the installer file. I'm going to click yes through any prompts that Windows may have. So yes. And now I have the install wizard. Now on this page, I want to deselect everything except for P4Merge. So I'm going to click here, and I'm going to choose this feature will not be installed and will be uninstalled if already installed. Of course, this is our first time installing, so this feature will simply not be installed. I'm going to do that for the next item down, and then also for the final item. This leaves us with Visual Merge Tool, or in parentheses, P4Merge. Once I'm content with that, I'm going to click on Next. And on this page, I'm simply going to click Start. Great, now P4Merge has been installed successfully. So now I'm going to click on Finish. And now I'm going to go look for P4Merge in my Start menu. Go to Start, All Programs, Perforce, and I should see P4Merge. And click on it, which launches P4Merge. I'm not going to do anything with this right now, and so I'm going to exit out. The next step is to set up P4Merge so it will be invoked from the command line without specifying the full path. To do that, I'm going to launch Windows Explorer. I'm going to open my computer, the C drive, Program Files, Perforce, and then I'm going to make sure I find the correct location where P4Merge lives. So this is the executable for P4Merge, so this is the correct folder that I need to copy. So now I'm going to go up here and click on the address bar for Windows Explorer, which converts this over to a regular path. So I'm going to copy that path. Now I'm going to go back to the Windows Start menu, go over here to Computer, right-click, go to Properties. Once the System page loads, go to Advanced System Settings. Once the System Properties dialog loads on the Advanced tab, go down to Environment Variables. Click on that button. Under System Variables, we're going to find the path variable. There it is. So I can either double-click or I can click on the Edit button. We need to go to the end of the path variable value and make sure the Perforce folder is specified here. If not, go ahead and paste in that value that we just got. Now that we've confirmed that, we can hit OK, 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 and now we can close this page. We can close Windows Explorer, and now we'll go ahead and close Chrome. And to verify that we can actually invoke P4Merge from the command prompt, we're going to go to the Start menu, Then go to the search box and type CMD. And then find the program named CMD, which is the Windows command prompt. Once that loads, type P4 merge. Once you press enter, this dialog should appear, which is the dialog for choosing files within P4 merge. So now that we've done that, I'm going to exit out of here, and I'm going to close the command prompt. Welcome. In this video, I'm going to demonstrate how to set up P4 merge on Windows with Git. Let's start off by invoking Git bash. Once Git bash loads, let's make sure that we can invoke the P4 merge command directly from the terminal. So type the command P4 merge, then press enter. If this dialog shows up, then you know this was successful. So let's go ahead and close out of here. Let's configure Git to use P4 merge as the diff tool and as the merge tool. Let's start with the diff tool. So we're going to use Git's config command. So git space config space -- global, because we want this to be a global or user level setting, and then the setting name diff.tool space, and then the value P4 merge. Press enter. Next, let's type git config space -- global, then diff_tool dot P4 merge dot path space, and then in double quotes the path to the P4 merge executable. So you will want to double check the path on your system. In my case, it is // and in Git bash I'm using the / and not the traditional backslashes in Windows. Program files / perforce / P4 merge.exe, and press enter. By default, Git will prompt you whenever you issue the diff_tool command, so we want to disable that behavior. So type git space config space -- global diff_tool dot prompt space, and then the value false, and press enter. Alright, so let's verify this so far. Git space config space -- global space -- list. Great. And towards the bottom, you should see the diff_tool and the diff.tool settings as we set above. Let's go ahead and clear. And let's move on to the merge tool. So git space config space -- global space merge dot tool space, and then the value P4 merge. Press enter. Then the command git space config space -- global space, and then the entry merge tool dot P4 merge dot path, and then in double quotes the full path to the P4 merge executable. So again, double check the path on your system. On my system, it is // program files / perforce / P4 merge.exe. Now in Git bash, I'm going to use the / instead of the backslashes. Now press enter. And like the diff tool, we want to also disable the prompt on the merge tool. Git space config space -- global space merge tool dot prompt space and then the value false. Once you've done that, press enter. Let's verify that by listing our configuration. Git config --global --list. Great. We should see both our diff and merge tool configuration listed towards the bottom. Welcome. In this video, I'm going to walk through how to install P4Merge for the Mac. P4Merge, which is a very powerful merge tool, is available for free from Perforce. Once the Perforce homepage loads, go to the Products menu and find the Perforce Clients and Tools. Once you click on that menu option, click on Visual Tools, and then click on the Download button for Visual Merge and Diff Tool. That takes you to the section for Perforce Clients. I'm going to scroll down until I find the P4Merge Visual Merge Tool. I'm then going to confirm that I have the correct selections, that I'm on a Mac, that I want the 64-bit version, and that I have the latest version of that client. I'm going to click Accept and Continue. When this page loads, you could enter your information here, but I'm going to skip registration. Once that happens, the P4Merge begins downloading. Once the download is completed, open the download stack and click on the P4V DMG. The installer we downloaded also included other Perforce clients, but the only one we need is the P4Merge. So select P4Merge and drag and drop it into Applications. This effectively installs P4Merge. Now close the volume, and now eject the volume. I should be able to use Spotlight to look for P4Merge. The first time you launch P4Merge, the Mac will prompt you to make sure you want to open it. Click Open. And now this is the initial screen for P4Merge. Now that we've confirmed that P4Merge works, let's quit P4Merge. Once we've confirmed that we can access P4Merge through Spotlight, let's make sure that we can access P4Merge from the command prompt. So launch your terminal, and once terminal loads, type P4Merge. Now press enter. That same P4Merge interface should load, and in order for the command prompt to return, we need to fully quit P4Merge, which is Command Q. Now that we've done that, it's safe to close our terminal. And that concludes the P4Merge installation. Welcome. In this video, I'm going to walk through setting up our Git repository in order to demonstrate several comparison scenarios. As a reminder, I'm using the fork of a starter web project from SCM Ninja. So now I'm going to go to my terminal program. I'm currently in my user's home directory. So now I'm going to go into my projects folder and then into my starter web Git repository. So if I do an ls, I notice something that is missing from this repository, and that's a README file. So let's create one. Mate space readme in all caps .md in lowercase. This is a standard naming convention that GitHub uses for README files. Alright, so let's go ahead and create our README file. Now, as indicated by the .md extension, this will be a markdown formatted file, which is really just a glorified text file. So a single pound is the first level heading, followed by 2 pounds is the second level heading. I'm going to add a couple of sections here. So at the top, I have Starter Web Project, which will be the heading for my README file, followed by 3 sections: Introduction, Purpose, and How to Contribute. Go ahead and save, close, and quit. Do a git status, and I have my README file that's untracked. If I do a git add README, we have staged the new file, readme.md, and now let's commit. Now let's go ahead and push this change back up to GitHub. Let's go to our browser and refresh. GitHub will automatically display the contents of the readme.md file formatted as if it were HTML. And you can see the README file is there. And if we go to raw, you can see the raw version of that file. Great, let's make a few more changes to that file. Let's continue editing the README file. Let's add a section called Deployment. Save and close. Quit. Let's do our express commit. Adding new section, Deployment. Git status. We're back to a clean directory. So now let's push. All right. Let's refresh. And we have our deployment section in our README file on GitHub. And let's continue editing the file some more. All right, now I'm going to save and close. We have our modified file. See, adding description. One more time. All right, so I'll put another paragraph under introduction. Let's save and close. Adding introduction text. Save and close. Instead of committing that revision, I'm going to add it to the index. So I'm going to stage the change to that file. So now if I do git status, you see our existing file, readme.md, is in the modified state in Git staging area. Let's modify that same file again. All right, save and close. So now if we do git status, we have the readme.md file in the 4 main phases of Git. Our local working directory in a modified state, Git staging area, in our local Git repository that's already been committed, and some commits that are already on GitHub, which represents our remote side. So great, I think our repository is ready to get into several of our examples regarding comparisons. All right, well, I'm going to pick up right where I left off. So I'm currently in my Git repository. So if I do a pwd, you can see that I'm in the starter-web Git repository underneath projects within my user's home directory. If I do git status, you can see that my working directory is not in a clean state. In fact, we have a handful of changes here. Now, it's certainly possible that I had started working on the README file and then got called away, which left my README file in an unfinished state. The git status command tells me that the README file has been modified, but it doesn't tell me what's been modified within that file. In order to get more detail about that, we can use git's diff command. So if I type git diff without any parameters, Git responds by comparing the differences between what's in my local working directory that has been recently modified but not yet staged versus what's currently staged. Now if I press Q to quit, I return back to the prompt, and I'm going to go ahead and clear. If you have a visual merge and diff tool configured and set up for Git, then we can use Git's diff tool command to visually see our changes. Git diff tool, and then press enter. Once you press enter on the Git diff tool, Git will launch our visual diff tool for us. So now we can easily see the minor revision made in the working directory. So on the right hand side is our file that is in the working directory that has been recently modified, and the rest of this file is what's currently staged, or the state of the file that is currently staged. So I have p4merge as my visual diff tool. p4merge requires that I completely quit before I can return to the command prompt. So Command Q. Now I'm back to the terminal and ready to move on. Alright, now that we know the difference between the working directory and Git staging area, let's see how our working directory compares to the last known commit. Let's do a git status. And so our git status command just tells us that we have modified files, but doesn't tell us the contents. So now if we do git diff, and then the pointer reference head as our parameter, Git will compare the difference between the working directory and the last commit on this branch. So you can see in this case that we added a couple of sentences, one under each section. So let's quit out of here. And let's do the same thing, but using the visual diff tool. Git diff tool head. The diff tool command will use the same parameters as the git diff command. Now you can see with p4merge, the two sentences that we have added at the various parts of the file. Again, the right-hand side is the current working directory, and the left-hand side is a temporary file that represents the state of this file on the last commit on the current branch. All right, so let's close. All right, so far we have covered how to compare the current working directory changes versus the last known commit, as well as the working directory changes versus what's been staged. So what if you want to know the difference between what's been staged and the last commit on the current branch? Well, there's an option for that as well. Git diff -- staged space head. We're comparing the staged area to the head, which of course head means the last commit on the current branch. So great. So this is the one line that was added that's in the staging area that's not in the Git repository. Let's see this change visually. Git diff tool -- staged space head. Again, on the right-hand side, you can see our staged file. And on the left-hand side is the file as of the last commit in the current branch. Now, let's close out of here. Alright, so sometimes your diffs involve multiple files, and you want to just limit that search to just one file. Let's set this up right quick. If I do an ls, you see we have our README file, but we also have our simple.html file. Let me modify that. Within the title tag, I'm going to put simple title as my page title. Save, close, quit. Now if I do git status, Git shows me that I have two changes that are not staged. The previous readme.md file change, as well as the simple.html change that I just made. If I do a git diff, I have both the readme file changes and the simple.html changes listed in my diff. So let's do the git diff again. We're going to limit the diff to just the readme file. Git diff -- space and then the path that you want the diff. So readme.md. Now the diff returns only the change involving the readme.md file. The same trick works with the git diff tool command. So we can see our change that's only involving the readme file. If we command Q, we return back to the terminal. We don't involve the other file. Alright, well, let's continue on. So far, we've been able to compare the differences between the three local states of Git: the working directory, staged, and the last commit. Now let's compare an arbitrary commit to the last commit. To do that, I'm going to use the git log command. Git log -- one line. This will give us our history of the commits that's happened so far, abbreviating the commit ID next to each one. So let's just pick a commit somewhere in the middle. So with the git diff command, you can specify two arbitrary points to compare. So git diff and then reference 1 and then reference 2. So the first reference I'm using is a commit ID somewhere in the middle of our history. The second reference I'm using is the pointer head, which points to the last commit in the current branch. Then you press enter, and now you can see the differences between all the changes that have happened across several files from the last commit to the specified commit. An alternative syntax would be git diff head and then head again with the up caret. This compares head and then head -1. To see this visually, we could do git diff tool head up caret. And now we're able to visually see the difference between the last commit on the branch versus the commit just prior to the last commit. All right, Command Q to quit. I'm going to use my git log command again. And now I want to compare two arbitrary points. So git diff, and then commit ID 1 versus commit ID 2. And again, we can see the differences between one side and the other. There are cases where one side is referenced by dev null. That means that this file didn't exist prior, followed by the other side, which actually specifies the file, which means in this case, this entire file was new. We can try the same thing again with a visual diff tool. Diff tool, commit ID 1, followed by commit ID 2. You can see on one side the file contents and then the absence of that file. You can see that the way that the visual merge tool works is that it will compare one file at a time. So I'm using Command Q to quit so that I return back to the terminal so that Git can then feed the next file to the visual diff tool. Alright, I've cycled through all the files that were different. Alright, so the final example I'll show you is how to show the differences between two branches. And since we haven't created any branches within the Git repository that we're currently working on, I'm going to compare the differences between the local master branch and the remote master branch, which will work just the same. Do that. We're going to type git diff. And basically with the git diff command, you can do right side compare versus left side compare. So I'm going to put master on the left side and origin master on the right side. Origin is the name of the remote reference that points back to GitHub. And /master is just the master branch on the Git repository on GitHub. So now I'm going to press enter. These two lines don't exist on our Git repository. They are the differences between what's been committed in master versus what's been pushed up to GitHub. So let's see this more visually. Git diff tool, master, and then origin /master. Press enter. So you can see here that master is on the left-hand side and origin master is on the right-hand side. That is, the right-hand side is the state of the file that is currently in GitHub versus the last commit on the master branch. Or you could say it's also head. Alright, so once you're done with that, Command Q. And if there were any other files involved with that comparison, then it would just cycle through. Alright, now that we've reached the end of the comparison section of this course, I'm going to do a bit of cleanup before we move on. I'm currently in the working directory of my Git repository. If I do a git status, you can see that my working directory isn't exactly clean. So let's go ahead and commit the changes that I have. First, I'm going to add everything to the index. That consolidates everything into the staging area. And now I'm going to go ahead and commit those changes. So updating repo with changes from compare section. Git status tells me that I'm back to a clean working directory. However, I'm ahead of origin master by 3 commits. So let's go ahead and do our update. So best practices first, git pull. We're already up to date, which I expected. Now let's push. Git push origin master. Great. Now let's go back to GitHub. And we should just reload the page. And you can see the commit message that we have, updating repo with changes from compare section. As well, you can see all the changes that we've made to the README file that were part of this section. Welcome. In this video, we're going to get started with branches in Git. I'm going to open my terminal. I'm currently in my user's home directory, and now I'm going to go directly into the Git repositories working directory. So now you can see where I'm at right now. If I do git status, you can see that I'm on the master branch and that we're currently up to date with origin master and the working directory is clean. So this is a pretty good starting point. So far we've been doing all our changes on master, which is not best practice. What we should be doing is separating our changes into branches that make the most sense. At the simplest level, we should be at least creating feature branches or topic branches to isolate our changes and then integrate them back into the master branch once those features or topics have been stabilized. To work with branches, we'll start off with the git branch command. And we can start off by listing our existing branches with the -a parameter. Now, -a will list both the local and the remote branches, and the git branch command will put an asterisk by the current active branch. Now, if I want to create a new branch, I could also use the git branch command without any parameters except the name of the new branch I wish to create. So I'm going to create a branch called my new branch. So now if I do git branch -a, we have my new branch listed as one of our local branches available. I'm not in that branch right now, I'm still on master. So I need to use the git checkout command to switch branches. Great, so now I'm on the my new branch branch. If I do git branch, the asterisk has moved over to my new branch. Let's see what this looks like in history. Git log -- one line -- decorate. You'll see something interesting here. That the first commit that we have listed, which is our last commit, has several labels associated with it. So we have head, which usually points to the last commit on the current branch, origin/master, origin/head, my new branch, and master. So head and origin head are simply pointers to the last commit on the respective branches, both local and then remote. Master is the branch that we've been working with all along, and my new branch is the branch that we just created. Since we haven't made any changes yet, all those branch labels are pointing to the same commit. That's because branches are just labels. They're nothing really special. They're just pointers. Our new branch won't actually start to branch off per se until we start to have new commits that are unique from master. Well, I'm going to go back to the master branch. To do that, I'm going to use git checkout master. All right, so now we're back on the master branch. We could also use the git branch command to rename the branch. So git branch -m for move my new branch to new branch. Basically, the old name to the new name. If we do git branch -a, My new branch has been renamed to simply new branch. Also, if we want to delete a branch, for example, if we no longer need it or we never needed it to begin with, we can type git branch -d for delete and then the name of the branch. Now, for obvious reasons, you can't delete a branch you're currently on. So you need to at least be in a different branch before you can delete a branch. So pressing enter will delete the branch. Again, if we do a git branch -a, new branch has been removed. All right, let's get started with some actual branching and committing and merging. I'm in my terminal program, and I'm currently in my user's home directory. So now I'm going to go to our working directory of our Git repository. Currently have a clean working directory, and I'm currently on master. If I type git branch, that will list all of our local branches. Git branch -a lists all branches, including remote branches. Let's start off by making a branch to make an edit to our simple.html file. We're just going to change the title. So instead of following the two-step process that I had in the previous video, I'm going to do this all in one step. So git checkout -b and then the name of a branch you wish to create. So the -b parameter for the checkout command will create the branch before checking it out. So we have switched into new branch title -change. You can also notice that my prompt updated to reflect the fact that we're in the new branch title -change. If I do git status tells us that we're on branch title -change and that we're currently in a clean working directory. So I'm going to edit the simple.html file. So I'm going to change the title to an example website. I'm going to save and close and quit TextMate. Git status shows that we made a modification to this file. So now I'm going to do a streamlined commit. Git commit -am followed by the commit message changing title of HTML file. Great. So we've made that change. I do git log --1 line. You can see our commit right there at the top. So we currently have a committed change that's in the title -change branch, and we need to move it into master. First thing we need to do is actually change back into the master branch. So git checkout master. We are back in the master branch. Well, before I merge in my changes, I want to know what the differences are. And I realize that we just made a very trivial change and we just made it, so we should know what those differences are. But this is really for the sake of if you're making lots of changes, or those changes have taken a bit of time to make, it's good to review the changes before you do any merges. So git diff, and then the first reference versus the second reference. So in this case, reference means the branch. So the master branch versus the title -change branch. So now Git shows us the differences between those two branches. If you prefer to see this visually, you have Git diff tool master title -change. In my case, that brings up P4 merge, and it clearly and visually indicates the difference between the two branches. So master is on my left-hand side, and title -change is on my right-hand side. Once I'm done doing the comparison, I'm going to quit. And now I'm ready to merge in my change. So I type git merge, and then the name of the source branch that I want merged into my current branch. To title-change. Doing so, Git will respond with the results of the merge. It's updating, and then you see the hashes of the commits being involved. It then tells me that it was a fast-forwarded merge, and the file involved with this was simple.html. That there was one file changed, one insertion, and one deletion. The way that Git sees a change on the same line is a line deletion and then a line insertion at the same place. Since this was a fast-forwarded merge, effectively what just happened was Git just placed all the commits on the master branch as if we never branched away. Fast-forwarding is only really possible when there are no changes being made on the target branch, which is what we just did. We branched away, we did some work, and then we came back and then merged into master. We didn't do any additional work on master before doing the merge. Git log -- one line -- graph -- decorate. You can see that head is pointing to the latest commit on the current branch, and that both title change and master are currently pointing to that commit as well. All right, let's list our branches. Git branch. We have master and title-change. And since we have merged in all the changes that are on title-change, we no longer need that branch. So let's delete it. So git branch -d for deletion, and then the name of the branch, title-change. So now our branch has been deleted. If we do git branch, we only see master. We'll do our git log command again with the one-line graph and decorate options, and our top commit, we only show master and head. All right, well, let's pick up where we last left off. I'm currently in the working directory of my Git repository. If I do git status, I'm currently on master, and I have a clean working directory. And right now, with git branch, I see that I only have the master branch listed. Let's create another local branch. I call this add copyright. Git checkout -b add -copyright. Press enter. Now that branch has been created and we have switched into it. Do git branch. You can see that add copyright is now listed and it has the asterisk next to it. Let's add a copyright notice to the beginning of the simple.html file. Alright, so added a quick HTML comment to add a copyright notice. Save and close and quit. Back at the terminal. If we do git status, we can see we have a modified file, which is the simple.html. Alright, so git commit -am. That's our shortcut for add and commit. And then our commit message, adding copyright notice. Press enter. Let's go ahead and edit the README file as well. So I went to the bottom of the readme.md file and added a copyright section and then put a copyright notice in there. So now I'm going to save and then close. Again, commit -am and then the commit message, adding copyright notice to README. Alright, so now we have two commits that are part of this branch. If I do a git log -- one line -- graph --decorate. You can see we have our -copyright at the top. All right, so press Q to exit. So now let's integrate those changes into the master branch. So we need to switch back to the master branch first. Then let's do git merge, and then the name of the branch, add copyright. Now this time, I want to preserve the fact that we branched off. So I'm going to disable the fast forwarding capability. So that means I'm going to specify the -no-ff option. Now when we do that, that's going to result in a merge commit. And so we're going to end up with a commit message, which the editor displays as merge_message. So now we want to save and close. So now Git uses any text that was in the text editor as the commit message. So now if we do a git log, you can see the graph line being preserved. So now that we've integrated those changes, we can get rid of that branch. Git branch -d, add -copyright. All right, so we've deleted that branch. Now if we redisplay our log, you can see that we just don't have those labels associated when we branch off. The branching still occurs, we just don't have a label associated, that's all. All right, so let's continue on. So now we have covered how to create a branch, do some work on it, and then merge it back into master, but in the happy path scenario where we result in a fast forward merge. Even going as far as to disable the fast forward merge scenario, but we still have that condition present. So the next step is to go through the process, but this time there will be an automatic merge that will result in a merge commit automatically. So I'm currently in my terminal, and I'm in the Git repositories working directory. If I do a git status, you can see that I'm on the master branch. We're a few commits ahead of origin, and we have a clean working directory, which is a good place to start. Do git branch, you can see we're back to having only the master branch. So let's go ahead and get going. All right, so I'm going to create another branch called simple changes. So git checkout -b, then the name of the branch, simple-changes. So our new branch was created and we have switched into it. So let's edit a couple of files independent of each other. I'll first start off with humans.txt file. So let's go ahead and edit this team information. All right, so I've added my name, my email address, and my Twitter handle. I'm going to save and close. Do a git status. We have our modified file. So git commit -am, that's our streamline commit. And in quotes, our commit message, adding team member to humans.txt. Great. So I'm done making changes to this branch. So I'm going to switch back to master, git checkout master. However, before I merge my changes in, I'm going to make a change to a file while I'm master. This could be done by another developer, or you could be making this change just by context switching and fixing something on production. So let's update the README file. All right, so I've added some text under how to contribute. Please fork this repository and then issue pull requests for review. Save and close. Git status, we have a modified file. All right, git commit -am, and then quotes, our commit message, adding instructions on how to contribute. Great. Now if I do a git log dash dash one line dash dash graph dash dash decorate dash dash all. Now towards the top is the interesting part. We have a commit that's on simple changes that's different than the commit that's on master. So from master, we're going to issue the merge command. I'm going to issue the git branch command to remind myself the name of the branch. All right, great. Now let's merge. All right, so merge simple dash changes, which is the name of the branch, and then the dash m parameter, since I know that this merge will result in a commit. And then in quotes, our commit message, merging changes from simple dash changes branch. Press enter, and it merged in the humans.txt into the current branch. So if we repeat our git log command, so you can see that when the merge happened, that we have our merge commit and that simple dash changes is still preserved as a separate branch. All right, so we're done with simple dash changes. So now let's remove it. Git branch dash d simple dash changes. Great, like before, only the label simple dash changes has been removed. The branch itself is still intact. And let's go check out humans.txt to make sure that change made it in the master. So that looks like the change that I made, so I'm happy with that. If we open up the readme.md file, and we still have the text under how to contribute. All right, welcome back. In this video, I'm going to cover how to resolve merge conflicts. Most of the time, you'll end up doing fast-forward merges or merges that could result in fast-forwards, or Git's going to be able to resolve the merges automatically. However, sometimes you're going to run into conflicts and you're going to need to resolve them. So I'm in my terminal. I'm currently in the working directory of my Git repository. If I do git status, I'm on master and I'm several commits ahead of origin, but my working directory is clean. Since I've been cleaning up after myself all along, I only have master at this point. All right, let's get started. So I want to do some changes on the simple.html file on one branch, and then switch back to master and do similar changes in the same areas in that same file so that it will result in a conflict. Perhaps this might occur if you have two different developers or contributors working on different branches and then they have to come together and their changes are just not compatible. Somebody is going to have to sit down and work through the issues. So let's create a branch. So git checkout -b real work. So that will be our branch that we'll do some work on. So I'm updating the copyright notice at the bottom of the page using my company name in there. Just putting some dummy text in the content area. And maybe changing the title, calling it a great website. Save and close, quit, git status. We have our modified file. So git commit -am, and then our message, making changes to simple.html. All right, so we've made our change. Do git status. Our directory is clean on this branch. Let's go ahead and switch back to master. Git checkout master. Now if I edit that same file, so you can see the contents of that file are the same as if we never switched away onto the real work branch. So Git will, behind the scenes, change out all the files that are in that working directory to reflect the current state of the branch you're going to. So as I switch back and forth between different branches or different references within Git, Git is managing my working folder for me. Let's make some additional changes that are going to be conflicting. Let's create a title called A Very Respectful Website. Alright, so I've made some more changes to this file. And these changes should conflict with the other changes that I made in the other branch. So now I'm going to save and close. Git status. And this time I will go with git add. Add the simple.html file. Git commit. Invokes my editor. Alright, so adding a little bit more text here for my commit message. Adding conflicting changes on purpose for Git example. I hope this works, which I do. Alright, that looks good. Again, if we do a git log, -- one line, -- graph, -- decorate, -- all. Git shows us that our work is diverged, that we have real work and master with different changes. I'm going to use the git branch command to remind myself of my branches. And this is a great example of when using the diff tools would be very helpful. So git diff, and then the first branch name, then the second branch name. So master, and then real work. And now we have a comparison between the two branches. So we can see there's probably going to be some conflicts here. I can do the same thing visually by using my diff tool. And P4 merge launches, and we can visually inspect the differences between the two branches. So I'm going to quit out of there now. Well, let's go ahead and try to make the merge. So git merge, real work. So this is exactly what I want to happen. Typically, that's not what you want to do. But in order to show you how to resolve a conflict, I do have to make a conflict happen. The first thing we see is that Git did try to do the auto merging of simple.html. But it couldn't. It resulted in a conflict in the content. So, automatic merge failed. So now we have to fix the conflicts. So we're merging against master, and so we're in a merging state. We're neither in a clean working directory or a staged area. We're just in this in-between state of merging. So if I do an ls, you can see that we have our simple.html file. So let's take a look at simple.html. Mate space simple.html. So if you're familiar with other source control tools that are popular in the Linux or Unix community, then you'll probably be comfortable with the way that Git will mark up your file to show the differences. That might be a little off-putting, but Git will modify your file showing the differences. So for here, we have our head version, a respectful website, which head is referring to master, so our target, versus real work, which is a great website. If we scroll down, you can see the same types of edits showing the differences throughout the file. All right, let's close out of there. So if you're really comfortable with that, and it's only a handful of files, then then by all means go ahead and modify the files manually. However, earlier we set up the visual diff and merge tools so that we could do this with a graphical tool. So to invoke our graphical tool to help resolve our merge conflict, type git merge tool. And that will launch P4Merge. So we can do a little bit of resizing here. And P4Merge is a pretty nice three-way merge tool that we can use to resolve the conflicts. So I'm going to go through here and then I'm going to decide which one of these sides I want to win for each of the places that are conflicting. So according to P4Merge, I have 3 conflicts. So I'm going to use the next arrow to go to the next conflict, or the previous conflict to go to the previous conflict. All right, so I'm going to look here, and I'm just going to decide which one of these I want to win. All right, that one looks pretty good. Go down here. Maybe I want this one. And then finally, maybe I want that one. So as I resolve the merges, I'm going to pick and choose which side I want to win. And then when I'm done, I'm going to save the file. I'm going to do Command Q to exit P4Merge. And once I'm done resolving all the conflicts of the merge, I'm going to commit the changes. So git commit -m, and in quotes, my commit message. Done resolving merge conflicts. Once I've done that, you notice that my prompt has changed from master pipe merging to just master, which means I'm out of the merge conflict. If I do a git status, you can see that I do have one untracked file. And that's because during resolving the merge, Git will save off an original copy of the merge conflicts so that if something got lost, you can revert those changes. However, I don't want to track the .org files, so I'm going to go ahead and add that to my ignore list. So mate.gitignore. So *.org. That will capture any file that ends with .org. So save, close, git status. So now it's excluding the .org file. I'm going to add .gitignore. So I'm going to add the new changes of .gitignore. And then I'm going to commit with a commit message, updating ignore file to exclude merge temp files. All right, well, let's go ahead and do a git branch. I still have real work. Since I've merged in those changes, I'm done with that branch. So that branch is now deleted. Now if I do my git log again, I can see that the done resolving merge conflicts is my merge commit, followed up by the latest commit, which I needed to update the ignore file to exclude those temp files. All right, I think we're done with this example. All right, now that we've reached the end of the branching and merging section of this course, let's push our changes back up to GitHub. So I'm starting off in the working directory of our Git repository. If I do a git status, you can see, although I have a clean working directory, that I'm ahead of origin master by quite a few commits. So let's take care of that. First, I want to make sure I don't have any outstanding branches that need to be cleaned up. So it looks like I've been pretty good about cleaning up after myself. So I'm back to only having the master branch. So let's go ahead and push up. But before I do, as a best practice, let's do a pull. Git pull origin master. All right, we're all up to date, which is what I expected. So now it's safe to push. Git push origin master. Alright, looks like we're all done. Let's go to GitHub and actually verify. So on the GitHub repository, just reload or refresh. Here's my last commit, updating the .gitignore file to exclude the temporary merge files. And you can see it right there. So all my changes are there. Welcome. In this video, we're going to walk through the steps to do a basic rebase. Just as a reminder, I'm working with the starter-web repository that I forked off the SEM Ninja starter-web version of the repository. So I'm going to go to my terminal. I'm starting in my user's home directory. So now I have changed directory into the working folder of my Git repository. So now you can see where I'm at. I can see a list of the files that are part of this project. If I do git status, you can see that we're starting off with a clean working directory. Well, I'm currently on master. To start off with the rebase, I'm going to create a feature branch off of master, do some work, and then switch back to master, do a little bit of work, and then rebase my changes back into the feature branch. Okay, so I'm going to create a new branch called My Feature. So now I have created and switched into that branch. So let's edit the humans.txt file. Once the file loads, let's do a simple edit. So under the thanks section, I'm going to say thanks to all my students. You save and close. If I do git status, you can see that I have a modified file. I'm going to do the express commit with a commit message saying thanks to all my students. At this point, I'm done with my immediate changes to the feature branch. So I'm going to switch back to master. So git checkout master. All right, now I'm back on master. So now I'm going to make some modifications on master. Let's edit the README file. All right, once the README file loads, just find a place and just add some more text. So just towards the top of the file, I just added a sentence, adding a line for rebasing example. Now I'm going to save and close. Git status tells me that we have a modified file, which is the README file. So I'm doing my express commit with the commit message, adding one-liner to README for rebase example. All right, now that I've done that, let's go ahead and clear. Let's take a look at our history. So git log -- one line -- decorate -- all -- graph. So you notice here that we have master and my feature. They're on separate lines, and you can see the graph line diverging. So in a rebasing scenario, I'm not done with my feature, but I want to incorporate any changes that may have happened on master, so I don't have a massive headache when I go to merge later. So to do that, I can use rebase. So I want to actually rebase master into my feature branch. So I'm going to return to my feature branch, git checkout my feature. All right, now I'm back on my feature branch. Now that I'm back on the branch named my feature, let's rebase in any changes that we've made on the master branch, and then we'll see how that affected our history. All right, so let's use git's rebase command. And on the branch that you want to rebase into, we type git rebase and then our source branch, that we want the rebase, which is master. So git rebase master. Press enter. So our rebase command says that it's rewinding our head, which is our current branch, so that we can reapply any changes that we've made on top of whatever's happened on master. So now let's do our git log command. Again, git log -- one line -- decorate -- all -- graph. So now you can see that we have master applied and then we have the change on my feature applied. In order to make that happen, we had to rewind the change that happened on my feature, play back the change on master on the my feature branch, and then apply the change that happened on the my feature branch originally. In doing so, it's flattened out our history. It's also going to allow us to fast forward merge once we're done making changes on my feature. Let's make another change before we do that. Let's edit the README file. You can see that we have the version of the README file that was on master. And I just expanded that line with a comma, then more changes from my feature branch 2. I'm going to go ahead and save, close. Git status tells me that I'm on my feature branch and that I have my modified README file. Since this was a simple change, I did the express commit, git commit -am, and then the commit message, adding another change after rebase. If I do my git log again, you can see that the my feature branch has moved a couple commits ahead of master, with our last commit at the top. So at this point, I'm going to say I'm done with my feature branch. So it's time to go back to master and merge the feature branch back into master. Git checkout master. So we are now back on the master branch. Opening up our README file, you can see that the README file is reflected as of the last time we were on the master branch. I just wanted to show you that right quick to make sure you understood that Git was changing these files in our current directory for us. Git status. So now let's do git diff master my feature. The git diff command compares master branch to my feature branch. So you see we have a handful of changes. All right, so let's go ahead and merge those changes in. Git merge my feature. And you can see that we have ended up with a fast forward merge. If we do a git log -- one line -- decorate -- all -- graph, you can see that master is now caught up with the my feature branch. All right, now that we're done with the my feature branch, let's get rid of it. Git branch -d for delete my feature, which is the name of the branch. All right, we've deleted that branch. So now we only have master listed in our Git repository locally. We're going to pick up where we left off. So I'm currently in the working directory of the Git repository. And I'm currently on the master branch. So let's see the files that we have to work with. If I do an ls, you can see that we have several files to work with. So I'm going to do some changes in the simple.html file. So let's modify that file. All right. So I'm going to go up here to the comment, and I'm going to add a line. So adding changes before rebasing conflicts. Save and close. So let's commit that. So doing my express commit with a commit message, MB for a master branch, before rebase conflicts. Okay. Now let's branch off from here. So I'm going to create a branch called Big Trouble. So git checkout -b, Big Trouble. Press enter. We have switched to Big Trouble, and we can go ahead and start making some conflicting changes. So I'm going to edit the simple.html file. Alright, so I've made several changes to this file. So let's go ahead and save and close, and let's commit. So I'm doing the express commit with a commit message of FB for feature branch, adding some trouble to simple.html. So let's go ahead and press enter. Now let's switch back to the master branch. Alright, so now I'm back on master. So let's go ahead and make some changes on that same file. So now I've made some conflicting changes in this file on the master branch. So I'm going to save and close. And now let's go ahead and commit these changes. So doing the express commit with the commit message of MB for master branch. Conflicting changes brewing. Alright, so if we do git status, we have a clean working directory. If I do a git log --one line --graph --decorate --all, so you can see at the top that we have two commits, one on each branch. So we have our Big Trouble branch and our master branch, which are diverged. So we're going to pick up where we left off, and I'm currently in my working directory of my Git repository, and I'm on the master branch in a clean working directory. So we have our Big Trouble branch that we created in the last video, and I'm going to switch to that branch. So I'm currently on the Big Trouble branch, and let's just visually compare the two branches before we do the rebase. So git diff tool, and then the first branch name, then the second branch name. Alright, so P4 merge, which is configured as my visual diff merge tool, comes up and shows me the differences between the master branch and the current branch. So it looks like there's going to be several conflicts with the simple.html file. So let's quit out of that. So let's go ahead and try the rebase. So git rebase master. Now, as expected, the rebase resulted in a conflict. So the first thing I want to show you is that we can simply abort the rebase. Perhaps we've determined this is too complicated and would rather take a different approach. To do that, we'll issue the git rebase with the --abort parameter. So now we are completely out of the rebase. If I do a git status, we're still on the Big Trouble branch, and that we're in a clean working directory. If I do a git log --one line --graph --decorate --all, you can see that nothing has changed. We still have the two branches that have diverged. Alright, so we're going to pick up where we left off. So we are currently in the working directory of the Git repository. If I do a git status, you can see that we are on the Big Trouble branch in a clean working directory. Now, if I issue my git log command from the previous session, that has the options of one line, graph, decorate, and all, you can see that we have our two branches that have diverged. So let's go ahead and try to do the rebase. So git rebase master. Press enter. As expected, we'd ran into a conflict. So now we're in the conflicting state during the rebase. So I'm going to treat this like a merge conflict and use my visual merge tool. So Git merge tool, that will launch the visual merge tool that's configured with Git. In my case, it's P4 merge. And now I'm going to walk through and resolve my conflicts. So I think I want the changes from this side. Now over here, I think I want these changes. I think I'll take these changes. That looks pretty good. All right, so once you've resolved all the conflicts, go ahead and save, and then close. If we do a git status, you see that we have our simple.html file that is modified. You may need to add the simple.html file before you can proceed. So we have fixed all the problems with this commit in the rebase. So let's go ahead and continue. So git rebase -- continue. So great, we have resolved the rebase conflict. So great, now if we run our log command, git log -- one line -- graph -- decorate -- all, you can see that we have applied our master commit and then our feature branch commit. All right, well, let's continue on. Let's make another change. Let's modify that same file again. This time I'm just going to take this one out. All right, so I'm good with that. So I'm going to save and then close. So I am going to do another express commit with the commit message of adding changes after rebasing conflict. All right, that's done. So we're back to a clean working directory on the Big Trouble branch. If we do our log command again. So now we're 2 commits ahead of master with our latest commit at the top. Let's quit out of that. So now we're done with all our changes on this branch. So now it's time to integrate those changes into master. So git checkout master. So now that we're on the master branch, let's merge those changes in. So git merge Big Trouble, which is the name of the branch. The result is a fast forward merge, which is no trouble at all. If we do our git log command again, so now the git log command shows that we have master and Big Trouble pointing to the same commit, and that the branching graph is very flat. All right, so let's quit out of that. So I'm currently in the working directory of the Git repository, and I'm on the master branch, and I have a clean working directory. For this example, I'm going to go ahead and synchronize up to GitHub first. So I'm going to go ahead and do my best practice, pull down from master origin to make sure we're all synced up. We're all up to date, which is what I expected. Now let's push up our changes. Great, so we should be synchronized. So our git status tells us that we are up to date with origin master. So in this example, I want to show how to rebase any incoming changes from GitHub onto your local repository. So to demonstrate that, let's do a few changes first. To edit the simple.html file. So I'm just going to edit the copyright notice at the very end. So now I'm going to save this file and close. Now let's go ahead and commit that change. All right, so I'm doing my express commit, which is git commit -am, and then the commit message local : just so I can track this is a local commit versus the remote commit, updating simple.html copyright notice. All right, that's done. So now we're back to a clean working directory and that we are 1 commit ahead of origin master. All right, so let's go to GitHub. So I'm going to fire up my browser. And let's modify the index.html. And I'm mainly just doing this to show what this might be like if there was another developer contributing on GitHub while we were working on our local repository. So I've made that change. I'll go ahead and commit that change. All right, remote colon, and then minor change to index.html, just so I can keep track of it. If I commit the change, all right, so it's there. So this remote colon, minor change to index.html, this is the latest commit on the GitHub repository. If I do a git status, it shows that my branch, master, that's local, is one commit ahead of origin master. I know this isn't the case, so I need to update my references. So to do that, instead of using git pull, I'm going to use git fetch. Git fetch is a non-destructive command that simply updates the references between the remote repository and the local repository. All the references are updated, so we're good to go. So now if I do git status tells me that origin master and my local master branches have diverged. Well, let's say that I really want to continue working, but I'm not quite ready to merge my changes in like a traditional merge. What I'd rather do is keep my commits, my changes, ahead of whatever's on GitHub. But I want the benefit of any of the changes that may have occurred on GitHub. So to do that, we can issue the git pull command, but passing in an extra parameter to cause a rebase during the process. So let's do that. Git pull -- rebase origin master. So this is our standard command, except that now we're using the -- rebase option to cause a rebase instead of a normal merge. All right, now press enter. Great. So now we have rebased our changes from GitHub on top of our master branch on our local repository. So now if we do git status, our branch is simply ahead of origin master by one commit. All right, so we can see that we have origin master and then our master branch. All right, so we have reached the end of the rebasing section. So I'm going to do just a bit of cleanup. So if you do a pwd, we can see that we're in the working directory of our Git repository. So git status tells us that we're on the master branch. We do have a clean working directory, but we are one commit ahead of origin master. However, if we do a git branch, we see that we still have our big trouble branch laying around, and we definitely don't need them anymore. So the first thing I want to do is go ahead and delete that branch. All right, so git branch -d for delete, and then the branch name, big trouble. Git branch confirms that we have deleted that branch. All right, so the next step is to synchronize with GitHub. So I want to do a git pull origin master, and we are all up to date. So even though there is a different commit on GitHub than there is locally, we've already incorporated those changes by using the rebase command in an earlier demo. Let's go ahead and proceed with our git push. All right, so we have pushed up all our changes to GitHub. Let's go check it out. All right, so updating simple.html copyright notice, which originated from our local repository. Welcome. In this video, I'm going to walk through the steps necessary to execute a stash. I'm going to fire up my terminal program, and I'm currently in my user's home directory. Now I'm going to go into my projects folder and then directly into the starter-web Git repository. So you can see that I'm now within the projects folder and the working directory of the Git repository. If I do git status, you can see that I'm on the master branch and that we have a clean working directory. All right, since we're working on a clean working directory, I need to go ahead and modify a few files. So if I do an ls, you can see that we have several files that we could choose from. So I'm just going to modify the simple.html file. So I'm invoking my text editor, which is TextMate, and passing in simple.html. Just find a spot that we can just change. I'm going to update the title for the web page. All right, now that you've made your change, let's save and close. So now let's do a git status. So you'll notice that we have our modified file, simple.html. However, the simple.html file, in my case, is going to be a work in progress. I'm not ready to commit this file in its current state. However, I need to change gears and modify a different file for something that just has to get done right now. In order to save the changes that I have for simple.html, I can use git's stash command to stash away any changes that are work in progress, so that I can change gears and work on something else. So let's do that now. Just type git stash, and that's all you need. By default, it's going to execute the save command, but that's not necessary since that's the default command being executed when we invoke git stash. So let's do this now. All right, so we have executed the stash command. So now let's look at the state of our working directory. If I do git status, you can see, while we're still on master branch, that we have a clean working directory. There are no files that are not staged for commit or anything that's in the git staging area. If I open up my simple.html file, so if I specify mate and then simple.html, I can see that the title is back to where it was. All right, well, let's go ahead and do some changes. Let's modify our README file. For my quote-unquote emergency fix, I'm just going to improve the copyright notice with the phrase all rights reserved. Once that's done, save and close. If we do git status, we can see that we have our modified file. So now let's use our express commit. So I'm going to do git commit -am and then my commit message. Quick fix in production to improve copyright notice. Press enter. Now we've committed that change. If I do git status, my working directory is back to a clean state. Now what about that stash that we created for the simple.html file? How do we get that back now that we've completed whatever work we needed to do that was a higher priority? Now that's completed, we need to get back to our changes that we were working on before. To do that, we need to apply our stash. So just type the command git stash apply. Now that you've done that, let's review the changes that we have. The git stash apply will then give us a git status basically on our working directory, which confirms whatever actions the git stash apply command had to do. In this case, it put back the simple.html file into its original state, which is in the working directory changes. Git status basically gives us the same information. Let's open up the simple.html file to see its current state. As you can see, the title is back to the way it was right before we issued the git stash command. So now we can pick up where we left off and continue editing this file. Once you're done making any additional changes in this file, let's save and close. Now that we've done that, let's go ahead and commit our changes. Again, using our express commit, git commit -am, and then the commit message done with simple.html updates. Great, so we're done with our commit, so let's do a git status. So we're back to a clean working directory. However, we're not quite done yet. So let's look at the git stash command, but now using the list subcommand. So we have a single item that's referenced at 0, which is where we start off with any list. And it says we have WIP, which is work in progress, on master, and then a reference ID. Since we've already applied the stash, we don't need it anymore, which means we can drop the stash. So we can just issue git stash drop, and that will drop the last stash. Let's continue where we left off. So I'm currently in the working directory of my Git repository, and we're on the master branch in a clean working directory. So we're going to do a couple things with this example. First thing I want to do is point out that by default, the git stash command will only stash tracked files. So if we do a git ls-files, you can see a list of all the files that this Git repository is tracking, including the humans.txt file. So let's edit that file. Let's just add some extra text here. Please leave a review if you like this course. It's a little self-serving, but it is some text. Let's save and close this file. If we do git status, we can see that we have the changes not staged for commit. This is the status that's given to working directory changes for files that are being tracked by Git. However, if I decide to create a new file .txt. So I'm going to put some content in here. This is a new file. Whatever you want to put in here is fine. Save and close. And now if I do git status, we have a slightly different status for new files. These are files that Git is not tracking yet. So if I do a git stash will only get the modified file, which is humans.txt. If I do a git status, we still have the untracked files in our working directory, which means that our working directory is not yet clean. So I'm going to reapply that stash, and we're back to having both the untracked file and the tracked modified file. Now I'm going to drop that last stash. So now if I do a git stash list, there won't be any results. So we don't have any stashes pending. So we have a couple of options. We could just simply add the new file to the Git staging area, and once that occurs, Git will start tracking the file. However, if you're not sure if you want to add that new file, but you still want to stash it, so you can determine that later, then we can use an extra parameter for the git stash command. Well, let's do that now. So if we just do git stash -u, the git stash command will then include any untracked files that are not being excluded by the git ignore. Now if we do git status, now we have a clean working directory. Well, great. Let's look at our stashes. Git stash list. We can see that we have a single item on master. Let's go ahead and do some work. Let's edit the README file again. Just going to update a line to say that we're doing an emergency fix after our stash. Save and close. If you do the git commit -a without specifying the m parameter or the commit message, we can use our editor of choice to create our commit message. Quick fix after stash on README file. Now if we just save and close, our README file changes have been committed. If we do git status, you can see that we're back to a clean working directory. Great, so after we've done our emergency fix, now let's go ahead and apply our changes that we have in our stash. However, this time I'm going to show you a more express way of doing that. Before, we had to do two commands: git stash apply and then git stash drop, to simply apply and drop the last stash in the list of stashes. So now we can do that with one command. Git stash pop. For those of you coming from a programming background, this is like popping the stack. Great, so we have applied the stash. So now we have our modified humans.txt file and our untracked file, a new file.txt, back in our working directory. So you can also see the same command, drop the stash. So now if we do git status, we have our modified file and our new file. Well, I'm not really keen on the new file, so I'm going to get rid of it. rm, which is the bash command rm, a new file. So now we're just back to a modified humans.txt file. So doing another express commit with the commit message, updates to humans file after stash pop. Great, so now our changes have been committed. Git status confirms that we're back to a clean working directory. So I'm picking up where I last left off. So I'm in the working directory of the Git repository, and I'm on the master branch and in a clean working directory. So let's work with multiple stashes. If I do an ls, you can see the files that we have that are part of this repository. Now let's modify a few of these. I'm going to start off with simple.html. Just going to update the title. So now it says updating title for multiple stash example. Save and close. And now let's do a git stash. However, before we used just git stash, which is fine if you're just doing one stash at a time. But in this case, I actually want to specify save and then a message. So this one's going to be like a commit message, but for a stash. This will make it easier for us to differentiate between the different stashes. Great, so now I've created our first stash. Let's edit the index.html file now. I'm going to add some text to the title tag. Adding title for stash example. Save and close. Git stash. Save. And then our stash message. Index changes. Let's do one more. Let's change the sentence. Once we've made our changes, let's save and close. And let's stash that change. Git stash save, and then our stash message. README changes. Press enter. Now let's list back all our changes. Git stash list. That will list all our stashes. And you'll notice something interesting here, that the stash index is probably the reverse of what you're expecting, that the last stash is index 0. Now the index 0 may be a thing that's throwing you off as well, but that comes from a programming background where indexes of lists or arrays start with index 0. But the part that's counterintuitive here is that the last stash is index 0 and not index 2. So let's pick out a specific stash to look at. Git stash show, and then a specific syntax. It's called a reflog syntax, which will allow us to reference the specific stash to show. And that would be stash, and then the @ symbol, and then in curly braces, the stash index you wish to look at. In this case, I'm going to use 1. And then that comes back and tells us that the index.html is part of that stash. Let's clear. If I do a git status right quick, you can see we currently have a clean working directory. Now I'm ready to reapply one of the stashes. So just like in the other commands, we can specify the specific stash we want to apply with our git stash apply command. So let's do that now. We currently have a clean working directory, and I want to apply our middle stash. So to remind ourselves of our stashes, I'm going to do git stash list. Great. So now I want to apply the index changes to my working directory. To do that, I'm going to specify the command git stash apply, and then the stash reference, stash at curly braces 1. Once you've done that, press enter, and the git stash will apply that specific change that's captured in that stash. So now we have our modified index.html file. Git status tells us that we have our modified.html file, which is the same output from the git stash apply command. Like the other commands we've covered, the drop command will also take the stash reference. So let's do a git stash list to see our list of stashes. And now that we've applied the stash at reference 1, which is the index changes, I don't need them anymore. So I'm going to drop them. So now specify git stash drop, and then the stash reference, stash at, and in curly braces, 1. The stash has been dropped. So now if we do a git stash list, the index changes is no longer there. It's no longer listed in our list of stashes. Also, what's interesting is that the next stash available has gone in to populate the stashes at 1, which is the simple changes. So next, let's just say that the rest of the stashes I no longer need, for whatever reason. If I do a git stash list, you can see that I have 2 stashes in the stash list. I can get rid of all stashes by using the git stash clear command. Git stash clear. That will empty my list of stashes. So I'm going to press enter now. So now if I do a git stash list, I have no results. All right. So picking up where I last left off, I'm in the working directory of my Git repository, and I'm on the master branch, but my working directory is not clean. Coming from the previous example, we applied a stash that contains some modifications to an index.html. If I do a git stash list, I have no stashes. So along with that index.html file, let's go ahead and modify some other files. Let's tweak simple.html. So I'm making a simple title update here. Going to save and then close. I'm going to edit the humans.txt file. Going to add some more values to the technology area. Going to save and then close. So now if I do git status, you can see that I have 3 files that are modified. And while I'm working here, I'm going to go ahead and add one of them to the Git staging area. Let's add the index.html to the staging area. So git add index.html. So now if we do git status, we have index.html in the changes to be committed state, which is the staging area, and the rest are just not staged for commit. Basically, the modified files in the working directory. And just for a complete demo, let's add a new file as well. So new.md. Maybe it's a markdown file. So new file for a heading and just random contents. Let's save and close. One more git status. So we have files in 3 different buckets of Git. Changes to be committed, that's the Git staging area, that contains the index.html file. 2 files that are modified in the working directory. So that's changes not staged for commit. And then a new untracked file, new.md. So doing all this work, perhaps I realized that this really does belong on a feature branch, not against master. So one of my favorite ways to correct this is actually to use git stash to move all these changes to a feature branch. So let's do that. First, we need to add all the files that have been modified or that are new to a stash. So git stash -u. So using the -u parameter, we're saving not only the modified files, but also new files. Doing a git status shows that we are back to a clean working directory. So let's go ahead and apply the stash to a new branch. And to do that, we're going to issue the command git stash branch and then the name of a branch, which I'm calling new changes. I'm going to press enter, and several things happen all at once. First of all, a new branch is created called new changes. Then we switch into that branch, and then our stash is then applied, and at the very end, that same stash is then dropped. We can confirm that by listing all our stashes. It comes back empty, so there currently are no stashes in the stash list. And if we do a git status, it gives us the same output that our git stash branch command gave us. Basically, the same git status that we had back on master prior to issuing the git stash command. Well, now that we've done this, let's go ahead and commit our changes that we have. First of all, I'm going to just toss out the new file. I really don't want them. So rm and then new.md. And now let's add the rest of the files to the git staging area. All right, so let's do a git status. So now all three of our files that have been modified are in the changes to be committed state. That is our git staging area. So now all we have to do is commit. So git commit, that brings up my text editor for a commit message. Changes after git stash branch command. Now save and close, and we have successfully committed our change. So at this point, I'm going to say we're done with this branch, and now I'm going to integrate these changes into master. To return to master, issue git checkout master. All right, so we are back on master, and now let's merge the branch new changes. So git merge new changes. Now that we've done that, we resulted in a fast forward merge. So now let's get rid of the new changes branch. Git branch -d and then the name of our branch, new changes. I press enter. That branch has now been deleted. If we type git branch, that lists out all our local branches and master's the only one listed. So in this video, I'm just going to synchronize up my changes back to GitHub, something I like to do at the end of each section. So like in all my examples, I like to show you where I'm at. So I'm currently in the working directory of the Git repository. And I'm currently on the master branch and in a clean working directory. In particular, we're 5 commits ahead of origin master. So let's take care of that right now. As a best practice, I always like to pull before I do any pushing back to GitHub. Git pull origin master. Press enter. Looks like our master branch is up to date. All right, so let's proceed with pushing our changes. Git push origin master. All right, we've successfully pushed all our changes up to GitHub. So what we can do is go out to GitHub and go to our Git repository, and we should see one of our commit messages that we recently committed. All right, continuing on, I'm still in the working directory of my Git repository, on master and in a clean working directory. So if I use my git log command, git log --one line --graph --decorate --all, you can see that we have our last 3 commits associated with a tag. Let's say that we really forgot to tag something that should have been tagged, perhaps a major milestone. So I'm going to pick one of the commits down here, and I'm going to copy that commit, and back in my terminal, I'm going to use the command git tag -a for annotated, and then our tag name v-0.9-beta space, and then the commit where this tag should have been applied. Now press enter. When the text editor appears, put in a tag message, beta release 0.9. Save and then close. So now when we do our log command, we see that we have our tag associated with that specific commit. We can do it one more time. In this case, I'm going to say git tag -a for annotated, v-0.8-alpha, and then the commit ID, which I just pasted in. Now press enter. Now let's put in a tag message. Save and then close. Now if we issue our log command again, you can see the v-0.8-alpha tag associated with the commit AB0D621. Picking up where we last left off, in the working directory of the Git repository, on master and in a clean working directory, if I do a git log, you can see that we have several tags associated with various commits. But in a previous demo, we associated a tag v-0.8-alpha with commit AB0D621. Let's say that I really wanted it to be associated with this merge commit, the BD35D46. So I'm going to copy that. Well, there's a couple of approaches that we could take. The first approach is simply to delete the tag and then recreate the tag on the corresponding correct commit, or we can do it by forcing it. So I'm going to show you that. So type the command git tag -a and then the tag name v-0.8-alpha space -f for force, and then the correct commit ID to associate this tag with. Press enter. Doing that allows us to edit the tag. I'm put in parentheses that we have corrected this tag, then save and close. And the git tag command responds that this tag was updated, and it tells us where this tag was pointing to. So now, if we do our git log command, the tag has been moved to the correct commit. Alright, well, let's keep going. I'm currently in the Git repositories working directory, and we're on the master branch, and the working directory is clean. If I list our tags, you can see that we have several tags that have been created. If I look at our history using the git log command, git log --one line --decorate --graph --all, you can see where each of the tags associate with a particular commit, with our most recent commit being associated with the tag v-1.2. However, if we go out to GitHub, I'm going to go to the Releases tab, and this is how GitHub tracks tags. And currently, there aren't any. So I'm going to go back to my terminal, and the first thing I want to do is actually push one particular tag. So to push one tag, I'm going to specify git push origin, and then the name of the tag I wish to push. Once you do that, press enter. And what Git will do is look to see if there are any differences, synchronize the commits if necessary, and then push the tag. So now if we go back to GitHub and refresh our page, we have our v-0.9-beta tag. I'll move this over just a little bit. Let's double check our tag. So this is the commit ID that it's associated with it. If we go back to GitHub, it's the same commit ID. Right now, looking at my commit history, If I go to my commits, you see the commit that starts with 42 4F is the last commit that's on GitHub, which is this one right here, which is the commit that's associated with v-1.0. Now, if we push another tag, this time we're going to issue the command git push origin and then the tag name v-1.1. So not only did we push the tag named v-1.1, but the commits that were associated with that tag are also on GitHub. So now if we go back to GitHub and refresh our commits, we go back to releases, we can see that we have our v-1.1 pushed up to GitHub. If we click on that commit, you can see that we have the changes for that commit on GitHub. All right. Now there are still several tags that are not on GitHub. To push all of our local tags up to GitHub all at one time, we can issue git push origin and then our branch name, which is master, and then use the option -- tags. That will synchronize our master branch as well as push up any tags that are missing. So now if we return to GitHub, refresh, we now have an updated last commit. If we go to releases, you can see we have all our release tags. In GitHub, releases are tracked by tags. And for each of the tags, you can go to the ... and it will show you the tag message. It also lists which commit that each of these tags are associated with. In addition to that, GitHub automatically generates a zip file or a tarball that contains all the source as of that commit. What if you accidentally pushed a tag that shouldn't be on GitHub? How would you then delete a tag that's on GitHub? Well, we can do that by going back to our terminal. And I'm just going to use the list option with the git tag command, just to remind myself of the names of the tags. So in this case, I want to say that we don't want to publicize our alpha commits. So I'm going to use this syntax. Git push origin, which is a reference to the remote repository, and then : followed by the tag name. What this is literally saying is push nothing to this tag name. So now I'm going to press enter. The git push command responds by letting us know that the v-0.8-alpha tag has been deleted. We can go to GitHub and verify that, and now that tag is gone. Now we still have it in our local repository, but it's just not on the remote repository. In this video, I'm going to cover how to use tagging. In particular, I'm going to start off with lightweight tags in Git. So I have my terminal program open, and I'm currently in my user's home directory. So now I'm going to change directory to the working directory of the Git repository. Now I'm going to do a git status, and we are currently on the master branch in a clean working directory, and we are all caught up with origin master. Let's take a quick look at our history. So I'm going to use git log -- one line -- decorate -- graph -- all. Now that's a fairly long command, which you can shorten by using aliases, but for now I'm going to use the command in long form. So now I'm going to press enter, and you should see our history with the latest commit at the top. And the -- decorate puts these markers like head, origin/master, origin/head, and master into our git log output. Now head is just a pointer, and origin master and master are branches. Master, of course, refers to the master branch on the local repository, and origin master refers to the master branch on the remote repository. So we've made a lot of changes in our repository. I want to mark significant events or milestones in the repository, and the way that I can accomplish that is by using Git's tagging support. Tags are just nothing more than labels that we can apply at any commit in the history. So I'm going to type git tag and then the name of your tag. In my case, my tag with a capital T. Doing so, we'll have a tag created. And the type of tag that we just created is called a lightweight tag. It's simply just a marker on a particular commit. So if we go back to our log command, we have a new item at the very top. Tag : and then the tag name, my tag. All right, so let's quit. We can also see that tag in a list of tags. Now type git tag -- list. Now be careful, you need to specify the 2 dashes. Otherwise, you'll just create a new tag called list. So double check that and then press enter. And Git shows us that we have one tag named my tag. We can use the name of the tag in other Git commands as a reference. For example, we can use that with the show command. Git show my tag. And then Git responds with the commit that's at that tag. So I'm going to list my tags again. And for this tag, I really don't want to do anything with them. I'm pretty much done with them, so I'm going to delete the tag. So git tag -- delete and then the name of the tag, my tag. So now the tag named my tag is deleted. If we list the tags again, Git has nothing to respond with since there are no tags to be listed. If we issue our git log command, again, git log -- one line -- decorate -- graph -- all, you can see at the very top that our tag is not listed here as well. All right, let's pick up where we left off. So I'm currently in the Git repositories working directory, and I'm currently on master in a clean working directory. So now let's create an annotated tag. An annotated tag is similar to a lightweight tag, except that it has a little extra information. In particular, it usually has what's equivalent to a commit message, but for tags. So to do that, I'm going to type git tag -a, which specifies this tag is going to be an annotated tag, and then I'm going to use the tag name v-1.0. Since tags are often used to denote major milestones or version numbers in source code. Now press enter. Since the -a treats the tag as an annotated tag, our default editor is brought up for the tag message to be used with the annotated tag. So I'm going to use the tag message release 1.0. You could have a whole list of release notes in here, or any other information that is relevant to this tag. When you're done, just save and close. All right, so now let's list the tag. Git tag -- list. So you can see our v-1.0 tag. Let's see that tag in history. So type git log -- one line -- graph -- decorate -- all. You can see at the very top, our last commit has the tag associated v-1.0. Now let's show the tag. Git show and then our tag name, v-1.0. Now when we do the git show on an annotated tag, we get a slightly different output. Now if you remember from the lightweight tags, the output started with the commit and the commit ID. But with an annotated tag, we start with the tag and the tag name and the person that issued the tag command, and then the date that the tag was actually created, and along with the tag message. Then after that, you start with the commit ID and the rest of it. So I'm going to quit out of that. All right, so we're going to pick up where we left off. So I'm currently in the working directory of the Git repository, and I'm currently on the master branch in a clean working directory. If I do a git tag -- list, you can see that I have a tag named v-1.0, and that points to the current commit. So I'm going to do some more work, and we'll add a few more tags. I'm going to do an ls that will remind me of all the files that we have in this project. Go ahead and edit the index.html file, and I'm going to modify the title tag. So title for tagging examples. Now I'm going to save and close, and let's commit. When your editor appears, put in a commit message. So I'm using the commit message tweaking file for tagging example. Save and close. So let's do a git log. Git log -- one line -- decorate -- graph -- all. So our latest commit does not have a tag associated with it. So whenever you issue the tag command, it will apply that tag to the current commit. So git tag -a and then the tag name. In this case, I'm going to use v-1.1. My text editor comes up for a tag message. I'm going to call it release 1.1. Then save and close, and let's modify another file. Let's modify the simple.html file. Updating title for tagging compare example. I'm going to save and close, and let's commit that change. Git commit -am, and then our commit message, updating for tag 1.1. Well, it seems that I actually got a little bit carried away, so I want to amend my commit. So I need to type git commit --amend. Press enter, and that will allow us to amend our commit message. When your editor appears, just update your commit message accordingly. So I'm actually updating for tag 1.2. Now I'm going to save and close. All right, now that's done. Let's apply a tag to this commit. And there's another syntax we can use. If we type git tag and then our tag name, in this case v-1.2, and then after that a -m for the message, and then in double quotes our tag message, in this case release 1.2. Now press enter. That should create our tag. So now we can list our tags. Git tag --list. So you can see that at the top we have our v-1.0, which is what we started with, all the way down to the last tag we created, which is the v-1.2. We can see this in history by repeating our log command. Git log -- one line -- decorate -- graph -- all. Press enter, and you can see that we have tags applied to the last three commits: v-1.0, v-1.1, and a v-1.2. All right, now that we have that, let's show our differences between the different tags. So the most popular command to use for displaying differences in Git is git diff. So git diff, and then our starting reference to our ending reference. So in this case, our references are going to be our tag names. So git diff, and then v-1.0, space, and then v-1.2. So we're going to compare the differences between those 2 points. We can do the same thing with a visual diff merge tool if we have that configured. Git diff tool, and then like our diff command, we simply reference the first tag and then the second tag, v-1.0 space v-1.2. That brings up the first file that's part of the diff, which is the index.html file. So you can see the changes that we have made between the 2 tags. Once you're done comparing the differences, you can press Command Q to exit and advance to the next file. Now we're comparing the differences between the different tags with the simple.html file. When you're done looking at the differences, Command Q. And since that was the last file involved in our diff, we return to the command prompt.